And we are live. So, welcome to Climate Chat, everyone. I'm your host, Dan Miller, and we have a returning guest, Leon Simons, a climate scientist based in the Netherlands, who has an interesting picture through a porthole that we have on the title slide. You can see him there. He was not in the Navy. I checked on that. So, just enjoy his ships. Um, and Leon is a co-author with climate scientist James Hansen on a groundbreaking paper from last year, Global Warming in the Pipeline. And he's been back with us several times to update us on the latest climate science. And that we're going to do today. So the wake-up call that we're talking about, really, there's kind of two different wake-up calls. One is sort of a political wake-up call that obviously, at least in the United States, people are not taking climate change very seriously, voting for someone who says it's climate change isn't real and not a problem. That's certainly a wake-up call. But there's another wake-up call, and that is climate science. And climate science doesn't really care about our politics, doesn't care what we think about it, doesn't care at all. It's all based on physics. And that physics does respond to our actions as opposed to our beliefs. It responds to our actions, like putting, obviously, greenhouse gases in the atmosphere, but it also responds to our actions like cleaning up pollution from ships, sulfur pollution from ships, for example. And all of those things come together and, based on actual physics, create a different world that we're going to be living in. And we're going to talk a little bit about the politics side of it and the science side of it today. And I'll start off saying something about the current political situation and climate change. I think there could be a silver lining to what is happening politically, and that is that before Trump, with President Biden, for example, and also this also applies to President Obama, they spoke well about climate action. They said that climate change is a serious problem and that they were going to take action to solve it. I would argue in the Obama administration, almost no action at all. And then in the Biden administration, there was some strong action like the Inflation Reduction Act. But when you look at that, first of all, it's a nice thing. It's certainly, very good set of policies in there, but not really at the level needed to address climate change, number one. And number two, President Biden also approved the Willow Project and oversaw leasing of more fossil fuels on federal lands, which is not even something you could consider doing if you're really serious about climate change. The old saying, when you find yourself in a hole, stop digging. And that means stop all new fossil fuel infrastructure projects. You can't turn off fossil fuels tomorrow, but you can phase them out rapidly. We're not even talking about doing that. So we were in a situation where people were told that we were doing something about climate change when we really weren't. I mean, we were doing some things, but nothing really at the scale needed to address the problem. Now we're going to be in a situation where someone's saying we're not addressing the problem. It'll be very clear to everyone that we're not addressing the problem. And in either case, much more severe and escalating climate damage will be occurring over the next 4 years, certainly over the next 10 years and 20 years. No doubt about that. We're seeing the beginnings of it now. But of course, we get used to it. Maybe we think it's the, quote, new normal. It's not a new normal. New normal means that's the way it's going to be from now on. It's only going to get worse. And surprisingly so, I would say. I'm looking forward to Leon's. Yeah, my attitude towards it, I've been doing like climate talks and everything for like 20 years, telling people it's going to get really bad if we don't act. But back then, we didn't really recognize, any bad impacts that we would assign to climate change. I thought we would start to see these things when I'm as old as I am now, but only sort of be able to tell because the climate scientists told us that statistically we can see the change. I didn't expect it to be as dramatic as you can just see it all around you every single week with the crazy floods and this and that and the other thing. So it is scaling up rather quickly, but it's only going to get worse. And now it will get worse under a political system, at least in the United States, that is denying it. And that hopefully will cause some problems. Now, as a friend who I discussed this with said, so one of the possible responses is that the public rises up against inaction and demands action. 4 years later, we don't want to get hit by all this stuff all the time. We want someone to really act, and then we might get real action. But as my friend said, yeah, but you can also just get more authoritarianism. Just get people just look to strong leaders who say, I'll fix it, even though they're just lying to you. So that's also a possible outcome. That's a lot more to talk about that kind of thing, but I just wanted to open with that the little possible silver lining is to keep in mind that no matter what you heard, we have not really been addressing climate change. Emissions are at a record high. In order to address climate change, they have to be dropping rapidly. Europe just announced, I think it was an 8.3% drop in emissions. And I was just chatting with Kevin Anderson, someone we've interviewed a couple of times here, climate scientist out of the UK, who looks at carbon budgets. He wrote an article saying, essentially, that's BS for a whole bunch of reasons. One is it doesn't include shipping and airlines. This is the UK, by the way. It may be just the UK. I might have that. I'm not sure, actually, whether it's EU or just the UK. But it doesn't include shipping and that. And it also doesn't take into account equity. In other words, the developed world created all the emissions. But as we cut back, we're assuming that the developing world won't scale up their energy use. So you guys stay that way as we slowly, adjust our way of doing things. He also says that it relies too much on negative emissions technologies like carbon capture to make the numbers work. And so that basically that we're all fooling ourselves. With that intro, I'd like to turn it over to Leon Simons. Leon, welcome. Great to have you here. Love to get your thoughts on the politics, but especially on the latest climate science. I've been seeing a lot of your tweets recently about what's happening to ocean temperatures and things like that, and 2023, 2024 numbers, and it's all not fitting into the pretty little package that the climate scientists had a few years ago. We'll turn it over to you.
Yes. Hi, Dan. Thank you for having me on. Let me see. I think I can share my slides.
Yeah. I'll let you know.
Yeah, of course, with regards to climate, Trump, or with regards to many subjects, I think Trump is a really bad pick for the United States as a president. But also from a climate perspective, of course, we haven't, as you mentioned, we haven't seen any action that's necessary from any party. So it's easy to say, of course, Trump will be worse than Biden was. But during the last presidency of Trump, emissions decreased. And why was it? Of course, because of the COVID lockdowns. But if you would just look at the data, you would say, okay, the best president.
The best president ever for climate change. I hadn't thought of that before, but you're right, I guess.
Yeah, and of course that's ridiculous, and we know it's ridiculous because we understand what's behind it. But often you don't know what's behind all these changes that are occurring, and I've mentioned it also before that many would think that the coal consumption, coal production in the United States would increase under Trump because Trump digs coal, right? That was one of his main campaign points in the election at the time, and then coal decreased because of wind and solar are much cheaper, and because air pollution regulations and demand didn't increase. So and of course because of the COVID lockdowns and the recession. Mm-hmm. So I think that's important to look at, and that's also, if you see, I think there was some slides for some graphs from showing that there would be a reduction if Biden would have been elected, the emissions up to 2030 from the United States would have been 4 billion tons of CO2 equivalent lower than they would be under Trump. And I looked at the small print, like what derives that, and that's really mainly an increase in solar and a decrease in coal. And yeah, I don't know if if will that not happen with Trump?
Anyway, right. Just economics, not politics, but it's the cheapest form of energy. It is subsidized to some degree, but fossil fuels, of course, are subsidized much more. But under Trump, the subsidies could go away, but just wait a few years and the price will be below what the subsidy was anyway.
Yeah.
By the way, you're bringing up another point I was going to make later, but since you brought it up, there is another. These are. I don't think you can call it silver linings because this will not be good, except it might be good for climate. For the same reason that Trump had the great climate performance because of COVID. If he ends up implementing the policies he said he's going to implement, I'm not sure he will, but if he starts rounding up immigrants by the millions, and he also implements all his tariffs, he's going to crash the economy. And not just the economy in the United States, but all over the world. If he does that, that will be good for climate. It's not good. I'm not saying it's good, for people. Certainly in the short run, it may be good. I mean, there are a bunch of people that think the only solution to climate change right now is to crash the economy on purpose in order to stop emissions. Because, if you really had a worldwide recession or depression, you would actually have, lower emissions. And it wouldn't be pretty and it'd be horrible from many, many points of view. But just purely from an emissions point of view, we could have like 2 Trump presidencies where he was the best president for climate, even though he's the worst president ever.
But
so that was another point I wanted to make. Eli?
That ignores the 2.5 teraton elephant in the atmosphere.
No. I'm not talking about. That doesn't mean at all that climate things go away. I'm just talking about current emissions could drop.
Well, yes, but that, I mean, you said it would be good for the climate, and it's like, well, okay, so the 2.5 teraton elephant in the atmosphere doesn't grow quite as much, but it's still there.
We'll talk about that. Yeah. No, I think we're talking right now about politics and are the current leaders of the world taking climate action seriously? Step 1 of that is to cut our emissions. We have to do a lot more, of course, but cut our emissions. And under Biden, we weren't cutting our emissions. And by the way, there's one thing, and maybe Len, you could talk about this. Not only are we not dropping our emissions, but CO2 in the atmosphere is going up at an accelerating rate. In other words, the parts per million per year, I think, was the highest ever in the last year.
Yeah.
The increase, It used to be like, it wasn't that long ago, like 20 years ago, it was going up at, I think, 1.5, 2 parts per million, something, maybe 2. Now it's going up at 3 point something parts per million per year. And it
was also, of course, driven by record high amount of forest fires in Canada, which were really off the chart.
And also the record warmth, which I guess is tied in a little bit there too, but warmth.
Yeah, so the warmer oceans release more CO2 than colder oceans, or they absorb less CO2. So that also plays a part. But the analyses I've seen so far, and I think there's one coming soon, a new one from the global carbon budget. But what I've seen so far is that the reduced or the reduced carbon sink on land or increase emissions from land added a lot to that increase in the rate or increase of global CO2 in the atmosphere. So that indeed that plays a role. Maybe I can just show you.
You can do your slides if you want.
Okay.
Speaking of that, we did a show long ago on the Earth stopped greening 20 years ago. So one of the sinks is when we put up, let's say, a ton of CO2, that about a third of it goes into the oceans, and about 25% or something goes into the soils and the plants. And so the world gets greener because there's more CO2 helps plants grow. That's the theory anyway. But there's something else that happens called vapor pressure deficit, which is sort of the humidity levels under a warming world, and plants want it to be a certain way, and as it gets warmer, it's not the way plants like it. And so supposedly, the greening part has been of the CO2 effect has been offset by the vapor pressure deficit problem. And there's a show on that if you want to look at our archives there.
It's interesting. You can look at all these stomata, so these small air hole, or these holes in the leaves, which plants use to exhale CO2 and inhale CO2 and exhale oxygen.
Yeah. Anyway, so go ahead there.
Yeah. So let's so these are the global surface air temperatures from pre-industrial. It's 1850 to 1900 from the European ECMWF. So that's a European data set, and it shows of course the warming, and then so rounded upwards. 2023 was 1.5 degrees Celsius above pre-industrial. But then if you look at the past months, they were all pretty much 1.5 or higher. And then, of course, November isn't in yet, but that will be, I think, 1.6 or 1.7. And then that will make 2024 with December also likely well above 1.5. That will make 2024 about 1.6 degrees Celsius above pre-industrial. Yeah, and that's really not unexpected. It is expected. If El Nino had been stronger, I think we would have had even higher temperatures.
But to be clear, the current above 1.5 temperatures that we are seeing right now, that is without an El Nino. Is that correct?
Yeah, so of course there's still a lot of heat in the system.
It's like there's a delay.
And there's a delay, but now there's a delay of about 3 to 5 months. But El Nino has ended already for I think in May. So
Hansen predicted that the temperatures would start dropping in September, and this was like back in March or something, and that really didn't happen yet.
Yeah, so I think that's the energy imbalance. I think that's the next. So I just want to go back to the basics for a second, because I think that's been missing and I think there's a lot of confusion around what's driving climate change. Well, that's really the basics, like what you learn when you start learning about climate change. You learn about energy, and that's in watts per square meter. So how big you need to know how big the planet is. That's 510 million square kilometers. And so times a million to get square meters. And then you see so how much sunlight is coming in, how much is reflected in what, and that's average over the entire planet. So that's of course the 340 watts. If you do that times 4, that's incoming radiation. And then so the planet receives energy from the sun. Part of it is reflected, and then a part is radiated outward in the infrared spectrum. Heat, thermal outgoing radiation. And if this number minus reflected sunlight and outgoing thermal radiation is this, if that's the same, then there's no imbalance. So there's no accumulation of heat in the Earth system. So this is from the IPCC, the 2021 IPCC report, and there they use this number of the imbalance of 0.7 watts, 0.7 watts per square meter. But now the average of the past 4.5 years, it's 1.4 watts per square meter. So it has doubled from what the number the IPCC uses has doubled. So and that's in line with data from NASA, from NOAA, from even some of the skeptics who had been saying there's no increase in the rate of heat accumulation. Even their data shows that there's that it has more or less doubled. The rate at which mainly the oceans are accumulating heat. And here's the graph again of this is the absorbed solar radiation in black. So again, here's this 240 watts number. And you see that's a big increase in how much sunlight is absorbed. That's because less sunlight is reflected back to space. But there's also an increase in how much infrared radiation in red is going to space. But the absorbed solar radiation increased more than the outgoing long wave, the outgoing heat radiation increased. And that's of course the past 12 months. So the most recent 12 months was about I didn't update it with last month, but it's about the same as during the last very strong El Nino from 2015 to 2016. So you might think, okay, it didn't increase relative to that time, but during this period there was also a temperature increase of 0.34 degrees Celsius, which implies the warming rate of 0.4 degrees or 0.42 degrees Celsius per decade. So that's really enormous. That will be more than a doubling of the rate of surface warming. Because I just mentioned the heat uptake, but this, if we now have with the same energy imbalance, we have we see we have this with this enormous increase in outgoing long wave radiation, we have the same imbalance that's caused, of course, by this enormous increase in how much sunlight is absorbed. So this is the net flux, as I show here, 1.4 watts per square meter, compared to the greenhouse gas forcing. So that's how the climate is pushed into a warmer state by greenhouse gases, by the greenhouse gas we have put into the atmosphere. But that's not the whole story, because there's also something called aerosols, which cause a negative forcing, which push the climate, which push the climate into a colder state. I think, this is the same graph, but from 1750 to 2023. And again, you see that there's an enormous increase in the greenhouse gas forcing, and then the net forcing is close to 3 watts. But this from Forster et al. But they don't show that in recent years they even show that the aerosol forcing hasn't decreased a lot. But if you see the increase in how much sunlight is absorbed by the planet, that's increased by 2.3 watts per square meter. That's the annual peak of last year. And that's and more heat is radiated to space, so that reduces how much heat accumulates. But then you see that there's a big increase in the net accumulation of energy. So you have to take these both into account, and then either the aerosol forcing was much stronger, so more negative, or it has decreased from there, or it's now less strong than 1.2 watt, and it should be somewhere here. So that's a big question we have, because there's very big uncertainty in what the aerosol forcing is. So how much cooling or reduced warming comes from these aerosols. Let me see what I have here. And then back to these greenhouse gases, because there's been some confusion around this subject. Some may even imply that I was exaggerating to make things worse than they are, right? So this stupid "the truth is bad enough" narrative, which has been going around for a while, from different people saying this. Okay, there is not this. The greenhouse gas forcing from NOAA is about 3.5 watts per square meter, but they use the methodology from the IPCC. And if you look at all the greenhouse gas from the IPCC, you get 4 watts, even more than 4 watts per square meter. And why is this? And if you just look at the well-mixed greenhouse gases, and that omits tropospheric, that's a crucial aspect, tropospheric ozone. So from the surface to about 10, 12 kilometers in altitude, that's where the weather happens. There's an increase in how much ozone is there. So that's also greenhouse gas forcing. So that also adds to how much energy is accumulating in the Earth system. And stratospheric water vapor, and that's both natural, for example, this big volcano that put a lot of water vapor into the stratosphere, that's starting from 12 kilometers and higher there. That's the stratosphere, and also our greenhouse gas, mainly methane, cause more water vapor to accumulate in the stratosphere. So these are also greenhouse gas forcings. So that's what drives the climatic change, and those should be added to the total number. Otherwise, you omit about 16 years worth of CO2 emissions of forcing. So that's really, forcing is indeed, again, what drives the climatic change, and that's combined with, so here's again this graph, this just greenhouse gas, right? Here we compare this from global warming in the pipeline data, and when we compare from the past 130,000 years, the greenhouse gas forcing, so looking at all these different greenhouse gases which are found, the greenhouse gas concentrations are found in ice cores, where you have these small air bubbles, so we can analyze what the greenhouse gas concentrations were, and use that to base upon that the greenhouse gas forcing, and that's in watts per square meter here. That's over 4 watts per square meter relative to 1750. And that's equal to a doubling of, that would be equal to when the concentration of CO2 had doubled. And that's a stronger increase than the decrease was during the last ice age, the coldest point of the last ice age. But this is just part of the story. Then again, if you add aerosols to this, the number is not 4 watts, but it's lower. And there's a big uncertainty. I didn't include any uncertainty here, but just to show you then what we also did, in global warming in the pipeline, was that we looked at what did humans do in the past. In the past 6,000 years, we burned a lot of forests. Our ancestors grew rice. So that caused this greenhouse gas increase, right? So there was a greenhouse gas concentration increase over the past 6,000 years. But as if you can see here, this from 6,000 years ago, this is temperature anomaly. If you just, I'll get back to this graph later, but if you just look at this here, there's temperature, and there's been a decrease over the past 6,000 years in global surface air temperature. And why is that? Well, and that it's called the Holocene, which is the past 12,000 years. The climate, this state is called the Holocene. This called the Holocene temperature conundrum. Because the greenhouse gas concentration was increasing, you would think the climate, if you look at climate models, they would produce global warming, effect of global warming. But in reality, so from the proxies, if you analyze the data from pollen, from ocean cores, you see that has been a cooling, especially over the northern hemisphere, while greenhouse gas concentrations increased, as you can see here. So there was an increase in the greenhouse gas forcing, about half a watt. See, and that's again half a watt, maybe compared to this enormous spike, doesn't sound like much, but you really need to take that into account. So NOAA should communicate that, right? But why didn't the temperature increase? So we think that's because of aerosols. Because our ancestors were burning the grasslands to create fresh grass for the animals to feed, to create agricultural land, Of course, they use wood for cooking, so the millions of people around the world burned a lot of forests down and grasslands down, and that added a lot of particles into the atmosphere, which increased how much sunlight was reflected back to space and how much clouds formed. So what we think is that you really that could explain this Holocene temperature conundrum. And also, if you see, for example, this is the emission. It's funny because I live in Eemnes, and close to where I live, there was 150 years ago, there were some people drilling for water, and the ground they took up contained these shells, these special shells which from sea animals which you cannot find anymore in the North Sea around the Netherlands. And then they discovered that around 120,000 years ago, where I live used to be the ocean, used to be the sea. So our land was covered by sea, which had seashells, which are now living around Spain, in the Mediterranean even. So the sea was 2 degrees Celsius warmer where I lived, and the sea levels were 6 to 9 meters higher during this period, where you can see, if you include these effect of aerosols and you compare them, the greenhouse gas force, the total forcing from greenhouse gas and aerosols, you can see that the forcing was much stronger than it is now. And that's caused that contributed, these forcing contributed to an increase in ice melt, right? But if you see this 3 number, it's much higher than the median. So we are now entering a climate state, as I show here. This is also from Hansen et al. 2017. A graph where they compare the median. Again, this is the last warm period before the previous glacial period, where you can see where they compare the median to current temperatures, and then they have different analyses of the temperature during the median. And if you see the model, they use here the 11-year average, but if you just look at the past year, it was about 1.55 degrees Celsius above 1880. It's 1880, yeah. So, I have a typo here, but it's 1880 to 1920. And this graphs the 11-year average, but the past year was 1.55 degrees Celsius. This year will be about 1.55 degrees Celsius above. And of course, it's not the long-term average, but it is a wake-up call. This should really be a wake-up call, because during the median, again, we are now, especially if you look at sea surface, temperatures are probably already higher than any of these data sets, because the land was warmer and a lot of ice had melted, and the land that was covered by ice was also warmer than it is now. So if you take that into account, then the ocean surface temperatures are now already higher than they were during the median. So that's really worrying, because that indicates that if that warm water starts to melt the ice, of course, we can have very rapid sea level rise.
So Leon, we've talked a lot about this in the past, but I think it's a good time to maybe summarize. So a lot of climate scientists look at this and go, wow, this is really strange. We don't know what's going on. We're going to have to go back and look at our models and everything. But you and Jim Hansen have been fairly straightforward of what you think the driving forces of this extremely rapid, because it's a huge jump in just a couple of years. And maybe you could just summarize that for everyone so that they get an understanding of what you think is the driving force behind this mind-boggling change.
Yeah. So of course, what causes global warming is the increase in greenhouse gas concentrations in the atmosphere. So we are creating a thicker blanket, or we are keeping more heat from the sun, which I showed you. This heat from the sun that's coming in that's absorbed that heats the surface, and the surface warms and it starts radiating heat back to space. If you increase the amount of greenhouse gas in the atmosphere, these greenhouse gases, they absorb this radiation, and then they re-radiate this heat back. And if you increase how much greenhouse gas there are, especially CO2, methane, and N2O, and certain other greenhouse gases, those cause more heat to accumulate in the Earth system. So that's pretty straightforward, and that's of course what was expected to happen. If you increase how much greenhouse gas there was expected to be more warming, and that's what we saw. But then in 1990, already James Hansen wrote in a paper where he said that together with these greenhouse gases that are emitted, inside the fuels there is sulfur, and if you burn these sulfur-rich fuels, mainly coal and oil, if you burn that, this sulfur enters the atmosphere, and it forms as SO2, as sulfur dioxide, and it forms these sulfate particles. And these sulfate particles are very small, but also very bright, and they reflect sunlight back to space. But what they also do is they make clouds form, because without these small particles, it's very hard for clouds to form, because they need water vapor. Of course, if you for example, if you exhale and you to a window, you can see that the water vapor from your breath condensates against the window. So and it doesn't, except if it's very cold. Normally, it doesn't condensate in the air. If you exhale, you don't see cloud form from your air. But if there's what these particles do, they also act as, like these windows, like condensation nuclei, what we call it. So that's where these small particles can act as condensation nuclei for all the water in the atmosphere. So, and then these clouds form. You see, for example, if you see an airplane flying through the atmosphere, through a level of atmosphere where you can see with observation system that there's water vapor inside the air, you can see when the plane flies through that, you can see a cloud form behind the airplane, right?
So I mean, just to emphasize what you're saying here, it's not just the particles themselves reflecting sunlight.
No.
It's that these particles help form clouds, make clouds last longer, make clouds brighter.
Yeah.
And so it's sort of an amplifying effect. It's not just the particles themselves. And that's a very key thing in what you and Jim found in the recent paper as well.
Yeah, and that's already it's not new information.
Right, but the effect is more than maybe what people thought, right? I mean,
yeah, but of course it starts with the basic. That's why I want to explain the basics. Okay, that's known for 30 for even longer, right? But for at least 30 years, we've known that if you reduce how much fossil fuels you burn, there will be more warming, because there will be less cooling. Right? So the net warming increases initially, and then the thought was, okay, then eventually, of course, the increase in greenhouse gases the greenhouse gas concentrations will also level off and then decrease as methane decreases in the atmosphere, and plants start keep absorbing CO2, and you will have then because these aerosols are washed out very rapidly within weeks, within days,
weeks. Right.
Within days and within days and weeks, depends a bit on the weather. But these greenhouse gases stay much longer. Methane.
Well, stop for a second. It's not a little bit longer, right?
In
fact, Jim's paper.
Methane start a bit longer,
15, 20 years. But the CO2, so this is Jim Hansen's paper, was called the Faustian bargain, or in other words, the deal with the devil. And the deal with the devil is you're going to burn fossil fuels and get energy from it. You're going to put CO2 in the atmosphere that's going to last for hundreds to thousands of years. And you're going to offset that warming with the smoke, coal smoke and things like that, that lasts for about a week or two.
Yeah.
So you have to keep doing it. And the moment you stop doing it, a week or two later, the cooling goes away, but you're left with this warming for hundreds of thousands of years. So that was the deal with the devil that he says is now coming due, that, we are cleaning up the atmosphere. This pollution does not just reflect the sun. It helps kill 8 million people a year.
Yeah,
Right?
that's of course that's the reason why you want to reduce that
There we
pollution.
go.
But that's so I was talking about this 1990 paper, and I think that this is also a figure, and I added some text here. So you have these greenhouse gas warming, which is like the devil, right? But there's also was this like cheap energy, and which of course caused this warming. But the nice thing which was also reducing the warming was the sulfur cooling. And of course, there's other aerosols. Black carbon causes warming because it absorbs heat, and other particles reflect sunlight. So the net, but if you average everything out, sulfur particles cause about 100% of the cooling from these aerosols, because some cause warming, some cause cooling, but these sulfur particles cause about 100% more or less of the cooling effect of aerosols. And that's why I think it helps to focus on sulfur if you talk about aerosols, because it's and in a strange way that it also of course relates to the devil and the sulfur and but in this 1990 paper by Hansen, the thought was that these greenhouse gas emissions would also decrease, because we would use less fossil fuels. But we are not using less fossil fuels. We are only reducing the sulfur particles by cleaning up our
sulfur
emissions.
Scrubbers and things. Yeah.
Or
desulfurization of fuel is the other thing.
Yeah. So here, this is a graph from the global sulfur dioxide emissions in 2010. And you can see, of course, you can see the land and where people live, and where, especially with the more industrialized countries in the northern hemisphere, and the 1.3 billion people in India, and 1.3 billion people in China, emitting a lot of sulfur.
Like mostly coal plants and industrial plants on land.
Mostly coal plants, and indeed, like in the industry that uses a lot of coal.
Right.
But what happened over the past decades was there was no decrease in fossil fuel use, a rapid increase in fossil fuel use globally. But countries like Europe and the United States and Canada and other countries and China also rapidly started to reduce how much sulfur they were emitted while continuing to burn fossil fuels. How did they do that? By either removing the sulfur from the fuel, especially from oil, by hydrofracking, where they use hydrogen to take the sulfur from the oil, because the oil that comes in has about 7 to 10%, at least in Rotterdam, sulfur fuel content. So they have to take that out they just scaled up that desulfurization, but also by using mainly gypsum in the smokestacks to wash out the sulfur from, or chalk to wash out the sulfur from the chimney, and then that forms gypsum, which can be sold on the market, which makes that also a very cheap way to reduce air pollution. Because if you think about reducing greenhouse gas emissions, of course, then it's quite expensive to take out the CO2, because there's not a big market for it.
Well,
right?
Another way is switching from coal to natural gas, and which theoretically reduces emissions, because natural gas, roughly speaking, puts out half the CO2 that coal does for every kilowatt hour of generation.
Yeah.
So you think you're cutting it in half, but you have methane, and natural gas is methane, and you have some leakage, and even a tiny amount of leakage, since methane is 120 times as powerful as CO2 while it's in the atmosphere. It does go away after like 15 years or so, but And it doesn't have the smoke, the sulfur, so it doesn't have the cooling effect. So you switch out the fuel, you on your accounting books, you say I'm lowering greenhouse gases, but in effect, you have immediately increased global temperatures.
Yeah,
and that's another, I think, big effect, because there's been a lot of coal to natural gas switching in the world in the last
so you reduce sulfur from coal, especially if you didn't have these scrubbers yet, you switch from coal, dirty coal, to clean gas, but you also emit methane, and so the greenhouse gas effect, especially in the short term, you increase the rate of short-term warming. That's crucial.
Now we see over the land areas, we have the dark red where there's more emissions. That's coming directly from coal plants and industrial plants. The yellow over the ocean is from ships, and that doesn't look as much, but I think the impact over the oceans is much larger than the impact over the land. Maybe you could talk about that.
Yeah,
and why that is.
Over 80% of these sulfur particles over the oceans were emitted over the northern hemisphere, of course, because that's where also 7 out of 8 billion people live, and where especially the more industrialized countries are. So that's and then we reduced these emissions by about 80% over the past, especially in 2020, when the global IMO 20 International Maritime Organization, its regulations came into effect to reduce these emissions to reduce the maximum sulfur fuel content the ships were burning from 3.5 to 0.5%, or use scrubbers to wash it out and dump it in the oceans. And again, that was for environmental and for health reasons. This regulation was introduced, and the ships are using. You can see if you look at the sales of these different fuels and of these scrubbers, you can see that ships are adhering to this regulation. Right. And then we see that in these regions, so the sulfur dioxide was cooling about 0.5 degrees, so between 0.2 and 0.9 degrees Celsius, up to 20. I think that's 2014, around 2014. So then, and that decreased the warming. But then, if you reduce that, all these sulfur emissions, especially over the oceans, which are dark, where there's not a lot of other anthropogenic, so human-caused emissions of aerosols to compete with, that causes a very strong forcing into causing more rapid warming, and especially more heat uptake, because you can think of it as of course the oceans it takes a lot of heat, a lot of energy to heat up the oceans and to warm the oceans by a certain amount of degrees, because they are very vast, very deep, and they have a very high, what we call specific heat content, because it takes it takes a lot of energy to heat water. It's about 3,000 or over 3,000 times as much energy to heat at the same volume of water by 1 degree Celsius as it does for the same volume of air. Wow. And then if you do, for example, if you heat the surface of the land, if you heat the land, then of course this energy doesn't penetrate the surface much. It just heats the surface, and then it's radiated quite rapidly as infrared radiation. And that's why you have faster feedbacks happening over land than you would have over the oceans. And then, of course, 90% of the heat uptake from the Earth's energy imbalance goes into the oceans. And that's one of the reasons why we think this forcing change over the oceans has much more effect than it would have if these same emission reductions would have happened either globally average or just over land. And that's what often simple climate models, they assume that this is just they assume this is like a greenhouse gas forcing increase.
It's all the same anywhere. Yeah, and that's why
and that's really bad science. And it would never be, it should never be, often it's not even published in a peer-reviewed paper. It's just they post it on blogs, but then many are citing it as if that's credible science. But in reality, that's not what happened. We see the very high increase in warming, in the rate of warming, especially over the northern hemisphere mid-latitudes, where all these emissions are being reduced, both from shipping and from these coal plants.
Right. I understand that what you and Hansen predict about this impact, it's 10 times more than what like Zeke Hosfather, who did it for the IPCC. They basically said, oh yeah, shipping emissions went down, but they did this average thing that you're talking about. And they say, it's
They
this
use the
much.
IPCC model where they just indeed assume, they assume that it's globally average aerosols changes, and they also assume that it's Forster et al. Published a paper about it where they show that the aerosol forcing in their what they published was the highest in 2023 it has been in 8 years.
With
They show
aerosol
the most
forcing,
cooling. They show the most cooling in 8 years. While
even though it dropped, even though we had the warm, right?
and you can say, how is that even possible? And that's because they assume that, and that's indeed the IPCC methodology. They assume that all these forest fires in Canada, all these aerosols from these forest fires in Canada are anthropogenic. So they, in a way, they would assume that it's all and then they put it in the model as a global average aerosol forcing instead of.
But it's still the Earth warmed anyway, even
and
with
these
this.
particles, and these particles are, of course, from these forest fires are in Canada, where, of course, the wind blows them at higher latitudes. Some drops on the Greenland ice sheet and on the Arctic sea ice, where it causes warming instead of cooling. Well, if you have all these sulfur particles being emitted over the surface of the oceans, that's especially the altitude.
Dark ocean.
Over the dark ocean, where they form these low-lying clouds over the dark ocean. That's where they cause a very strong cooling effect.
Right.
And that's this. So the science is, of course, there's some models showing a stronger effect, and some models showing a less strong effect. But if you look at it from a globally average perspective, and you don't take all these important spatial effects into account, then your outcome is wrong. But they just, but these simple models, they do give you a number. And then that's, of course, also what journalists love. They would just give me a number, they ask, right? But then the number is wrong. You know the number is wrong. They know the number is wrong. Those who give the number, they know it's wrong. But it's just an average. And but I think that's really dangerous in a way, because it underestimates the rapid warming, like what we have now, for example, in and also the weather changes, like we have now in, for example, over the Mediterranean, where you have these enormous, the enormous spike in temperatures over the Mediterranean, which causes much more water to evaporate and contributes to these, for example, these very strong floods in Spain.
Mm-hmm. Right.
And then next year, in May, so in less than 6 months, in May, there will be again a rapid reduction in sulfur emissions over the Mediterranean. And
it's important to point out, I mean, it's kind of obvious in our discussion, but it's really important to point out, when we talk about greenhouse gases and CO2, you can put it up anywhere and it affects essentially the whole globe because it is a well-mixed gas. It mixes everywhere. But sulfur particles, they fall out after a week. So wherever you emit them, they surround that area and then eventually fall out. So it's a local phenomenon. In fact, I read that Europe is the fastest warming continent on Earth, and partly because it's doing the best job in cleaning up its pollution, which is why it's warming so fast. I mean, Arctic's warming faster. It's not a continent, but it's warming faster for other reasons. But just in terms of sort of regular land masses, Europe is getting impacted very heavily because it's doing a good job in cleaning up its deadly pollution.
Yeah, especially in the summer. So what we call a aerosol termination shock. It's often used for geoengineering, but we use it also here, because what's called the aerosol, of course, these are these particles. The termination is stopping to emit them, and the shock is this rapid warming. And we use a threshold of 0.2 degrees Celsius per decade of additional warming caused by the termination of these aerosols emissions. And then what we see over Europe over the past decades, in the summer, it's the climate models show that this, especially when they look at these regional effects compared to when you don't take this into account, these aerosol changes, you see an increase in summer warming of over 0.2 degrees Celsius, additionally added to these greenhouse gas warming effects. So that's already, in Europe, we are already experiencing this termination shock in the summer. And that's, of course, regional. But what we think now is that we are experiencing also this termination shock globally. And that sounds bad enough, right? That sounds bad enough. But the effect is not global because these emissions were concentrated over the northern hemisphere mid-latitudes where all the ships were going. And that's where, if there's a global average increase in warming of at least 0.2 degrees Celsius per decade, regionally that's more than double. So you would do, so you have even much more warming, and again that causes more extreme weather. That causes these floods in Spain. I just heard it on the news. Are now considered the worst environmental disaster in 50 years in Europe. So that's
right. A whole year's worth of rain in what, 8 hours? A whole year's worth of rain in 8 hours. And now there's political, by the way, got to the politics. They're having big protests about how the government didn't handle that well. By the way, no government would have been able to handle that well. But there is going to be this. This is going to happen. I mean, this is kind of something we can be sure of. There will be more climate disasters starting right now. We don't have to wait. And they're going to get worse and worse and worse. And, we're seeing, and for every 1 degree of warming, you get 7% more water vapor. We're at 1.5, so we're getting 10% more water vapor, but it's not average. First of all, it sucks up water out of the ground, makes it dry, gives you fires and droughts, and then it dumps it all at once, and you get far more extreme weather. And people can go listen to our interview with Daniel Swain from a few weeks ago, who's focuses on extreme weather. I do want to ask you a question, though, the really basic question. This relates to the global warming and the pipeline paper. You showed the graph a little while ago showing this is greenhouse warming. Oh, this is aerosol cooling, the IPCC. And it said 0.5 degree of cooling, but with an error bar going to maybe 1 degree of cooling. But if you're right, what was that?
Up to around 2014.
Okay, that's 2014. But if you and Jim Hansen are right, my understanding is that, you have a certain amount. It's not a global average over the oceans. This less amount of sulfur is causing a much more cooling. And then over the land, this huge amount may be causing a little bit less, but overall it's much more. And so is that error bar incorrect? And the real number, and I'm just totally guessing at this, is closer to maybe 1 degree of cooling with an error bar of 1.5 or something.
Yeah, maybe.
Like that. Could it be as high as 1.5 degrees of cooling?
That's up to 2014, and that's so. How much warming would there have been up to 2014 without these sulfur particles? And that's a question.
Yeah.
Well,
make it 2014, make it 2024. I don't, whatever.
Sorry?
I'm saying give us a number for then and maybe for today,
I think it's, so that's what I was referring to when you would say, okay, you journalists just want a number, but you also just want a number, right? So, but.
Well, I want to know if they're really underestimating the.
Yeah, so I think we are really underestimating it because you have the greenhouse gas forcing now already, which is stronger than that has been in millions of years, in over 3 million years. So yeah, nobody knows what that would have been like without these aerosols, right? And you can have
well, you can estimate without knowing the impact, you can estimate it would be this much warmer without that much cooling.
But then you get you still again want to like the global average number, which in a way that if the AMOC shuts down, for example, the Atlantic meridional overturning circulation, all the heat that's transported through the Atlantic Ocean northward, and Europe receives about 30% of the heat Europe receives from the Atlantic Ocean, rather than and the rest from the sun, right? So there's a lot of heat flowing from the south to the north to keep Europe relatively warmer than, for example, Canada is at the same latitudes. If this Atlantic current shuts down, there will be a global temperature decrease. There will be cooling globally. And then you say, okay, that's positive, right? But but there will be an increase in how much heat accumulates in the Earth system. The energy imbalance will increase. Why is that? Because there's more heat going to the melting of, for example, the Atlantic
Antarctic ice, which is not a good thing.
Antarctic ice sheet, West Antarctic ice sheet. So while you care about the global, or many, I'm not saying that's all you care about, but while many care a lot about global average surface temperatures change, I live in the Netherlands. I live at about sea level. 30% of my country is below sea level. I care much more about, for my own country, right, about the global sea level rise, especially sea level rise where I live. And of course, I also very much care about all the other things that can happen if the climate changes rapidly. But I think that's the focus on global surface temperatures, and of course, I also look at it. But I think it's a bit simplistic, and that's why I think it's if you focus on this simple number of how much warming would there be, you don't talk about how much warming will there be, for example, in the Mediterranean. Maybe in the Mediterranean there will be. I think that's for me that's much more important question. Like, if without this air pollution, how much warmer would the Mediterranean be? Multiple degrees Celsius, I think. And that's
multiple degrees Celsius.
Yeah.
Wow.
So because that's what happened. So from 1980,
aren't they implementing more desulfurization of fuel?
Yeah. So but from 1980 to 2020, Europe warmed about almost 1 degree Celsius more, especially over summer, than would have happened without these aerosol reductions. So that's 1 degree, right?
Wow.
You mentioned this half a degree globally, which is interesting, but Europe has 1 degree additional summer warming already because of these clean air regulations. And we had 60,000 deaths in Europe in 2022, which about half attributed to global warming. And about, if you can say, okay, these much of this warming, especially the rate of warming, is caused by this desulfurization, this clean air regulation of Europe. So how many deaths are from clean air regulation? I think that's really a crucial question to at least to ask. And many are not even asking this question, right? And we need those. It's hard to answer, but we have to consider this, that around the Mediterranean, if the Atlantic Ocean warms more, and I don't know the number, and I haven't seen anyone even look at this. No climate scientist has looked at it. I've been on CNN Turkey to talk about it, but no climate scientist I know has done an in-depth analysis of what will happen if the Mediterranean, if the sulfur emissions over the Mediterranean reduced by another 80%.
Is that the
so
regulations that are pending?
May 2020. Let me get this graph back up.
May 20. By the way, the reason I was asking you the other question is because the highest level kind of view of your global warming in the pipeline paper, the way I look at it is that the warming from greenhouse gases is more than we've been assuming. Instead of a 3-degree climate sensitivity for a doubling of CO2, which we have now doubled CO2 on effect, CO2 equivalent. Yeah. So instead of 3, it's 4.8. So that's a very significant increase. But it also implies that, or you also discuss, that the cooling from aerosols is also more than we've assumed. So instead of this half a degree thing here, it's 1 or 1.5. And that means so both the IPCC using the 3 and the 1.5, they get it at the current temperature. They call it 1.5 for simplicity. And you and Jim would get the same 1.5, but by having a higher greenhouse gas warming and a higher aerosol cooling. So, but it has huge implications going forward. You say, well, why does it matter? You both end up with the same current temperature. Okay, fine. But as we clean up the world, we're going to end up with a much bigger surprise than we thought.
So the IPCC's one, or the Paris Agreement's 1.5 agreement, right? So they're keeping it warming close to 1.5 maximum. That's mainly, it's a political agreement, and it's about risks. It's about reducing risks, and the 1.5 is just a way to in my opinion, a very bad way to make it quantifiable. Because the agreement is, okay, let's reduce risk, especially for countries living, for example, in areas that are very hot already, or for island states that are already facing the effects of global sea level rise and losing their country, right? That's what this agreement was based upon, to reduce the risks of these countries losing their habitable land and their agricultural land. But if you have already, even without at 1.5 or at 1.4, the effects on global sea level rise will be worse. For example, because of this AMOC shutdown. If this new research shows that it's much more likely that the AMOC will shut down, as James Hansen.
We've covered that a lot on this program. Yeah,
exactly. As James Hansen already published about in 2016, that the risk is much higher than most assume. Then this risk of 1.5 is much higher as well. And it just as the risk of AMOC shutdown. They could have called it the Paris Agreement, the limit of AMOC shutdown, or of a certain amount.
Would have been a better metric, yeah.
Yeah, of about a certain amount of sverdrups or petawatts transported through the Atlantic Ocean northward, right? You could discuss it like that. I thought, of course, it doesn't sound as sexy as 1.5.
Right, it wouldn't work politically, I think. Yeah.
Keep 50 sverdrups alive or whatever, right? For the stable climate, that in a way that's as I tried to explain already, that's more important for people living in Europe, for example, or for these island states, that the West Antarctic ice sheet doesn't disintegrate because of much more heat staying south that's not transported northward through the Atlantic Ocean. And then am I showing this graph? Yeah.
You're showing, yeah.
So about the majority, 40% of all the sulfur from shipping was emitted over the North Atlantic, and of course also a lot of over the North Pacific. But that caused a lot of sunlight being reflected back to space and less heat uptake over the Northern Hemisphere. But if you increase or decrease the sulfur emissions, increase how much sunlight is absorbed, there's less heat transport. The imbalance of the Northern Hemisphere itself increases with space. So and there's less heat that needs to be transported from the Southern Hemisphere to the Northern Hemisphere to keep this balance of energy or this global energy distribution system as it is, right? So, and then if you decrease these emissions over the Northern Hemisphere, especially over the North Atlantic and North Pacific, you can in the models, in climate models, you see that the reduction in aerosols has much more effect on the AMOC than a same forcing in greenhouse gas emissions. So, of course, the shutdown of the AMOC will be in the models is from warming of the ocean and from input of fresh water, because salt and colder water sinks to the bottom of the ocean and transported southward. But if you warm the ocean and if you cause more precipitation, then that contributes to a slowdown of the AMOC as well. And that's all so certain data sets already show that the AMOC could be tipping as we speak, and as you've been discussing already with some other scientists on climate change.
So I see. So the decrease in ship emissions warms the ocean, causes more precipitation, which is fresh water. And when it comes down as rain over the oceans, and I guess over the lands too, and that puts more fresh water on the surface.
Surface, yeah.
Which is the thing that helps slow the AMOC down. Plus the melting. Now, the thing that will accelerate the freezing of Greenland is an AMOC collapse, but it'll be too late then. Because we also get fresh water from the melting of Greenland. I wonder if does the sulfur reduction help accelerate melting of Greenland? It's a little bit away from there.
More heat in the system over the northern hemisphere or the North Atlantic causes more melting, and of course it depends where this heat goes, right? If it goes to the if it causes evaporation, causes more rain in the Netherlands in Europe, that doesn't melt the Greenland ice sheet. But if you would have, for example, these atmospheric rivers bring rain, so liquid precipitation and heat, and also a lot of heat to the Greenland ice sheet, that could cause not just fresh water into the ocean, but also melting of Greenland, which also is, of course, fresh water, which would add even more fresh water. So that's possible. And it's very
By the way, this is basically what you're describing is we're doing solar radiation management. We're not doing it on purpose. Well, we're doing it knowingly. We're not doing it purposely. We're not doing it to cool the Earth, but it is cooling the Earth, and we know it's cooling the Earth. So we're doing it today, but this particular kind of solar radiation management, the sulfur falls out of the atmosphere every week or so. So it's something you got to keep doing, and you got to put a lot. I mean, I've heard the number about 100 million tons. Is that number right, or is it less than that per year of sulfur emissions?
So the current emissions of ship, or the emission from shipping was about 10 million tons.
From ships, but I meant including coal and everything.
Yeah, globally, I think it was at a peak about 100.
So let's call it a nice round number. But
100 million tons, and we reduced it already by about 40% or 50%. But
already, so down to 60 maybe, and that's why we're getting the warming.
And then before, because many think, okay, so we already caused a lot of warming, and we did over Europe, of course. But that you really have to take this non-linearity into account, that only small amount of particles can have more effect than
depending where you put them. Over a dark ocean,
of course, indeed. Yeah. So
then it has a very big effect.
So over the past years, when we were talking about these shipping emission changes, many said, okay, it's only 10% of all sulfur emissions, right? But that everyone who knows anything about aerosols knows that that's really a very a small part of the subject. Because if you have, for example, as many aerosols emitted over India, because these particles travel in the atmosphere, but they don't travel from India all around the globe constantly, and they have a very different effect. Regionally, they cause about even 16 watts per square meter of cooling over India. So that's really over some that's 1/6. And so that's during the day it's even more, right? Because they reflect at the surface. And this is at the surface, so it's not the total energy imbalance, or the total forcing, but this is at the surface. And that's also crucial to, maybe we can have a long discussion about what the difference between surface forcing and total forcing. But that's also important to take into account. Where is this energy reflected from or absorbed in, or if for example, this black carbon causes heat to be absorbed into the atmosphere instead of reaching the surface, that causes the cooling of the surface, but the heating of the atmosphere. So these are all these are things to take into account. But it just let me just go back to my slide.
Yeah, by the way, another important point that about the ocean versus the land. Over China, let's say, they're doing a lot of sulfur. If they cut that in half, they still have a lot of reflective particles around, still cooling the Earth, even when you remove half of them. But over the ocean, where there's really no other source of the sulfur, when you cut that back, you're really exposing the dark ocean. So cutting back a little bit over the ocean has more of a cooling impact than cutting back the same amount over land where there's other sources of reflectivity, including the land itself.
It's always difficult to give an example, but it's like if you wear 10 jackets over another, right? If you or 10 blankets, if you remove one blanket, you're still it will still keep you very warm. But if you only have one blanket, and you remove it, you will cool down.
That's a decent one. I was thinking other examples, but yeah.
This may be a better comparison for greenhouse gases, but it's not
a good idea. It's a good example.
Non-linear. So there's many examples you can give, but I always want to stay as close as possible to the subject at hand.
And by the way, tying it back to politics as well for a moment, I do think that the right shift in politics makes it even more probable, I thought it was very probable anyway, that we're going to end up doing solar radiation management on purpose. And we should mention a very big distinction between the current solar radiation management we're doing by accident versus if we did it on purpose. By accident, we emit the sulfur in the lower atmosphere where it lasts for about a week or two. But when we put it in the stratosphere, it lasts for a year or two. And so we need far, far less for cooling, and it's far healthier for humans if we put it in the stratosphere than the troposphere.
For example, if you would want to, it depends also where you emit it. If you emit it, and I think there's many people who can discuss this stratospheric.
Well, I think we're going to put it over the Arctic and the Antarctic to start with, because that's
maybe
cool the poles. And you can't put it over one. You got to put it over both.
You really need to take into account, for example, the effect of these aerosols over on the AMOC, for example.
Yeah, absolutely. To me, that would be the number.
You would do it over.
Not the number one reason, but one of the main reasons is to try if we can prevent an AMOC collapse.
So if you would do that, if you say, okay, let's cool the southern hemisphere, and then maybe you could cause the AMOC to collapse, right? If you do it at a certain scale and a certain location, and so it's possible that if you do it the wrong way, you cause you do more harm than you do good.
Oh yeah. Well, just by the way, the Arctic is warming faster than the Antarctic because the Arctic Sea is the white reflective ice is going away and it's dark ocean underneath. So it's warming 3 or 4 times faster than the global average. That's causing the jet stream to go crazy and be lazy and go up and down and all that kind of stuff. And that's giving us these crazy weather things where it was super warm in New York, 80 degrees in New York last week or something. And then it sweeps down the other way and you get snow in Texas. So it is causing crazy things to happen, but you have to be very careful when you do it, because if you cool one part of the globe and not the other, you change the wind patterns and all of that
wind
stuff.
patterns, ocean patterns,
everything.
Regional temperature differences. That's also what it's called marine cloud brightening, which we often refer to the intentional cooling of the oceans by reflecting particles over the oceans and creating clouds over the oceans. So one risk is one thing to consider is the change in ocean land temperature gradient, and that means the difference in how warm the oceans are, the surfaces of the ocean are compared to the temperature of the land is, and that causes also especially regional weather patterns. And then what we did now, it was change the region. Of course, we were unintentionally doing marine cloud brightening.
That's what we're doing right now, right?
To stop that, and that's again, I think that's really why I want to show this graph is also why, if we were doing also over the Mediterranean,
Mm-hmm.
causing regional cooling, and that changed that causes also weather patterns to change because you cool the Mediterranean more, for example, than the land.
Mm-hmm.
With this certain forcing, right? Not talking about, of course, these coal plants were cooling the land more than the ocean because they were over land on average, and depends a bit. If, it's not that easy. Depends, of course, where the wind, how the wind blows, etc. But these particles over the ocean, they cause the temperature gradient from land to between the surface of the oceans and the surface of land to increase. So the oceans were colder and the land was warmer because of these aerosols. Now we decrease these emissions already by about 80%
Over the oceans.
over the oceans, by introducing this regulation from decreasing the maximum sulfur fuel content from 3.5 to 0.5%. But in 2025 in May, so that's in less than 6 months, the maximum sulfur fuel content over the Mediterranean, so ships, cruise ships, ships transporting goods over the Mediterranean, which is if you see here, it's quite bright red, so that's quite a lot of shipping happening over the Mediterranean. Those ships can only carry fuel with a sulfur fuel content of a maximum of 0.1%. So that decreases the amount of emissions again with 80%. And as I mentioned, it's non-linear. So you might think, okay, you already decreased 80%. So that if you decrease it again by as much, it doesn't do that much effect. But it could have even stronger effect than this initial decrease of 80%. I don't know. I haven't seen the research because I don't think there is any research on this yet. Right? It's just all the communication I could find on this is, look what we're doing, we're decreasing the negative health and environmental effects of this air pollution, and that's fine, and I think that's laudable.
Wow.
I think good, but I don't know of any study looking at the regional climate and weather effects of this regulation.
Wow.
And we should look at that, right? Europe should take that into account. Europe should want to know this. All these Mediterranean, and not just Europe, right? I remember last year all these flooding in North Africa as well. So all these North Africa countries should consider this as well. What happens if these emissions change? What happens to the weather all around the Mediterranean? And I think that's a crucial question to ask. And also, we need to look at what happens. If you want to understand the biggest uncertainty in climate science, which is how much cooling do these aerosols cause, you have to look at these, what we call a natural experiment. And that's what many aerosol experts are looking at, these what we call natural experiments, like a volcano eruption, or like these changes in regulations causing a change in emissions. So we look at these and we really need to look at what happens over the Mediterranean already, of course, and over the past years, and we've been looking in detail over at what happens over again. It is the North Atlantic.
Well, don't we have enough now can't you write a paper right now? I mean, isn't let's get through 2024 and get the final date on 2024.
Yeah, but we published already a paper called Global Warming in the Pipeline, led by Hansen, where we show in these regions where most of these sulfur emissions were happening from shipping. So it's only 10%, right? It's only 10% of the global sulfur emissions, but over the oceans, it's 100%. So 100% of the we're getting sulfur emissions happening over the oceans were from ships. And if you reduce that by 80%, then you reduce all the emissions that are happening over the ocean by 80%. Of course, some blows over land, but that's really what you see over these regions. then this is the absorbed solar radiation, average of 48 months. You see there's this enormous increase. Here's almost 4 watts per square meter over the North Pacific. And that's here you saw a spike, and that's of course also from the Pacific decadal oscillation, as our co-author Norman Lowe wrote a paper about in 2021, where they said, okay, if the Pacific decadal oscillation, or the cycle in the Pacific Ocean, if it changes back to negative, we should see a decrease in how much sunlight is absorbed over the Atlantic Ocean and globally. But we saw a big increase.
Right. And the control, which is the Southern Ocean, didn't go up.
Well, there's been negative.
A little bit, but yeah. No, it went down. Actually, it went down. Yeah.
Sorry?
In the Southern Ocean, the same absorbed solar radiation actually dropped a bit in that same time period.
At the same latitudes over the southern hemisphere, there was a decrease in how much sunlight was absorbed. And we compare these regions because, of course, there's also sulfur emissions from shipping, right? So and again, because it's non-linear, we shouldn't neglect these. We shouldn't say this doesn't happen. But
what about the sea ice, though? The sea ice has been really dropping rapidly around Antarctica. Is that included in that area? Because
no, that's south. This is south of this.
It's south of that.
This is from 20 to 60 degrees south.
Okay, it doesn't have sea ice. It looks like it goes right up to the coast.
Yeah, it's inside this region. So it's maybe sometimes there's a bit of sea ice in this area, but it doesn't go that far north generally.
Okay.
Especially in the summer months when the sun is there, there's not much sea ice there. But of course, the cold oceans also get more clouds because as we have now in the Netherlands, when it's cold, we have a 2 or 3 kilometer thick cloud decks over the Netherlands.
Yeah, I was going to say that so many people object to solar radiation management done on purpose because they think it's screwing around with the climate, and we're certainly screwing around with the climate. And I think the thing that they don't quite get is that there's this, and I don't hear it talked about much. CO2 is forever. You put it up there, it accumulates, it causes warming for hundreds of thousands of years. Aerosols change rapidly, like within weeks. So if you somehow you could cut it all off tomorrow, 3 weeks later, you're going to have a huge spike in warming. And so when they look at it, climate's the 30-year running average of weather and all this kind of stuff. When you make a change, like in the shipping regulations, that's like an on-off switch. And to me, I said, like, you're measuring the temperature in your house very carefully, and you're marking it down every hour, and you're watching the trend, and maybe during the daytime of it warming up. And then someone turns on the air conditioner or opens a window or something to change it. And there's a big change. And you say, no, but we have to take the long-term average. No, wait a second. You made an abrupt change to something in the system. The long-term average no longer applies. You've all of a sudden, just totally changed the watts per square meter here. And I think that's why I think we have to look at the 1.5 degree number over a much shorter time frame and look, what is the average temperature where natural variations go above it and below it, like El Nino, La Nina, and what's in between, that's the temperature we're at. And by every measure, we're at 1.5. Well, yeah, by that measure, we're at 1.5 right now.
And taking into account this, the energy imbalance, right? Because if you say, okay, it's very hot. For example, I saw Gavin Schmidt, I called it a cheap shot, saying, those who were talking about the energy imbalance when it was so very high, stopped talking about it for some reason. I don't know why, right? And then and now it's the energy imbalance is going down, and why did they stop talking about it? And New Scientist wrote on the basis of that, wrote a nice article saying, it's not as bad as some thought. The truth is bad enough, right? The same shit as we had 2 years ago for 2 years now. And it's like, what caused it? Like it's interesting to see, okay, the energy imbalance decreased. I think that's interesting, and I think that it was expected, because that's the very basics of climate physics. that if something warms, it radiates more heat to space. If you look at the IPCC,
Right.
they use a number
to the fourth power of temperature.
Yeah, so they use this is a standard. It's called the Planck feedback. So how much does the outgoing long wave radiation, so the outgoing infrared radiation, increase when temperature increases? And they use a number there, and with a very small uncertainty, they say about minus 3.22 watts per square meter. So that's negative. That means that more heat is going out of the Earth system for every degree Celsius of temperature increase. And then if I look at this at the NASA data, the temperature data, and I multiply that by this increase in outgoing long wave radiation with the Planck feedback, you can see that as the temperature increases, if you compare that to this observed outgoing long wave radiation from these satellites from NASA, there's a different range within NASA, right? So there's for example, Gavin Schmidt is a successor of James Hansen,
right?
They work there. Hansen was the director. Now Gavin Schmidt was also on your show. Is the director of NASA GIS, but that's different from the part of NASA that has these satellites, because they do the modeling. But the ones that have the satellites that look at the data from how much sunlight is coming in, how much sunlight is reflected back to space, that's a different branch. They are at Langley, and they produce this data. So this is the temperature data from NASA using climate models, and the data from observation systems on land mainly, to look at how did the temperature change. And this is a satellite, and you see, of course, as the temperature increased, multiplied by this number, you see that more heat is leaving the system because of this Planck feedback. And that's quite in line with what we see in the data. But there's a change here, and that's the increase in greenhouse gases mainly cause more heat to be absorbed. So there's a relative decrease in how much, there's an increase in how much heat is radiated to space, but a relative decrease because of the increase in greenhouse gases, including water vapor, which is a feedback.
I remember the one thing I remember from my astrophysics class in college is that luminosity equals 4 pi r squared sigma t to the fourth. And it's that last term, t to the fourth power, is the thing that's operating here. As something heats up, it radiates a lot more.
So that's a lot of watts.
And that's what's been keeping the Earth that's the number one feedback that keeps the Earth relatively, stable, is as it heats up, it radiates more energy away, and that cools it down and keeps things relatively stable.
It's called a negative feedback, which is a bit for daily language is a bit strange, because it causes cooling,
it's a good feedback,
which people think is positive, right? But it's called a negative feedback because it reduces the amount of warming, and that's really, every degree Celsius of warming, there's about a 3.2 watts per square meter increase in how much heat is radiated to space. So that's really a big number.
So, what's your feeling, by the way, on the based on what's go ahead.
So if you see that the temperature increased by over compared to the last El Nino by about 0.35 degrees Celsius, then it's
0.3, a third of a degree.
Over a third of the degree. Then, and you multiply that by this 3, then it's expected, since they see 2016, it is expected you are expected to see an increase of about 1 watt, right? 1 watt in outgoing long wave radiation increase, and that's more or less what we see. But the increase in absorbed solar radiation is higher, and that's why even with such a big increase in temperature and an increase in how much heat is radiated to space, the energy imbalance didn't decrease, it stayed about the same.
Yeah, well, so what was
So
the word about it going down? You were just talking
that's-
about Gavin talking about it went down, but did it go down, or is it more recent, or what are we talking about here? This is recent data, right?
It went down compared to this. You see here this here.
Okay.
So
Yeah.
it's lower than the peak.
Okay.
It's lower than the
Of course.
peak. I think it's about 1.94, 1.94. So then, but that peak caused a lot of heat to accumulate in the Earth system, and that heat is still there, and it's not going out because the energy imbalance is still positive. Which, based on that, with this temperature, we
Still
shouldn't.
absorbing more heat.
And that's answering your question. Like, should we see a decrease in temperature? Well, not as long as the energy imbalance is a negative, right? There's still more heat accumulating in the Earth system. So I don't expect to see a big decrease in temperature yet, as long as we are increasing the greenhouse gas concentrations at record speed and still decreasing how much sulfur we are emitting, especially over the oceans. So,
well, the Earth energy balance
this is-
always been positive for a long time, right? We do see drops because of short-term variations like La Nina, but are we in a La Nina right now?
no temperature, we see a temperature decrease during La Nina, but not a decrease in the energy imbalance.
Oh yeah. Well, that's why. Okay, I thought we were talking about energy, temperature.
Yeah,
So
no, we should, during such a hot El Nino as we had, where with temperatures, depending a bit what you use, but using the 1.6 degrees Celsius from NASA, then you would estimate that there's a big, that we would see an energy imbalance decrease, which we see, but not as much as I think many would have thought it would decrease. And that's because there's still so much sunlight being absorbed, right, compared to how much was absorbed in the first decade of the century. So that's you have to take that into account. And if you just say, okay, let's look just at this net effect without looking at what makes up this net effect, I think that's you're just fooling yourself in a way. And I think that's I don't want to, like, I wrote about this somewhere else on Twitter, saying with great power comes great responsibility. You know, Kevin Schmidt is the director of NASA, so he should be held accountable for what he does. And if now we, for example, he also changed the baseline. I think I showed someone else on your show was confusing the baseline a bit before, but now
famously,
Kevin was changing the baseline for he uses I think 1880 to 1899 baseline, which is about 0.5 or 0.6 degrees Celsius lower. So the baseline is warmer than what Jim Hansen and all.
wait. What? No. I think that doesn't sound right. What baseline is he using? 18. What?
1880. Yeah. So, I
1880 shouldn't be 0.5. It might be 0.1 or 2.
Well, let me
versus 1850 to 1900, right? Is sort of the standard baseline that Jim uses, right?
Let me get to
it can't be that different from 1880.
Yeah, it is. Let me show you.
It is? Okay.
I was surprised as well.
Half a degree? 0.5? Okay, you're frozen, but that might be because you're pulling up something.
Yeah, so and I looked it up, and then so anyone listening, so anyone listening, please look it up. It's on the
Okay.
If you just look at
well, let's say it again. Say the two baselines again.
So if you look at NASA GISS, you can get and you look at the temperature. You can find it on their website. You have to look a bit, but you can find it where it says the temperature from the ocean and the land surface. You can find the data from 1880 to 1990 and calculate.
Oh no, to 1990. Oh yeah. Sure.
1880. Let me just put it up because it's easier just to show you.
Sure. I mean, I'm sorry. I thought you meant
1880 to 1899.
Oh. Okay.
Yeah. It's a bit.
All right. Well, all right. That's a surprising thing, but
Yeah, I'll just show you because it's. I know it's surprising. I was surprised as well. So this is one. And now we use the different baseline again, and that decreased the baseline. Increased the warming, the baseline warming with 0.3 degrees, and that's a total effect of 0.8 or 0.9.
I'm looking up one of them here, but
No, I'll show you. It's easier.
okay, you pick it up. You pick it. Trying to find it.
No, it just takes me a second to put it in the slide deck. But then you can see. I was looking at it today, so it's quite clear.
Okay, this one here says, come on, blow it up. with respect to 1951 to 1980. Well, yeah, of course, that's a huge difference. But that's just showing a lot of them use more recent climatologies, and that's not unusual. You have to reset them back to pre-industrial. So this one says 1950, some NASA data, GISS, but it's okay.
No,
Leon, can you remind us what the offset is between 1951 to 80 and pre-industrial?
it's here.
Here we go.
I'm showing. Wait, let's start with this. So yeah, James Hansen et al. in the research. James Hansen founded this data set, right?
1880, 1920.
He was the lead scientist.
1880, 1899. But that offset, if you look at the yellow line in 1880, it's not a big deal. It looks like it's off by at most less than 0.1 degrees. 0.05, it looks like, right? Is that what you're saying? 0.05, not 0.5.
0.05. Yeah, sorry.
Oh, okay. All right. That's fine.
I wrote it wrong as well. So
okay.
sorry for that.
We corrected. Oh, there it is, right there in the middle. 0.05. That's fine. 0.05 I'll take. I don't mind a 0.05 degree difference. And by the way, what is pre-industrial? You could go to 1750 and maybe that's more accurate. But then we have everything you were talking about. We have the aerosols, the rice farming,
Let's first get this clear. Sorry, I misspoke.
Okay.
1880 to 1920. If you look at 2023, the temperature is 1.44 degrees Celsius.
Right.
Of this period, right? And you can see there's some volcanoes here, but so this baseline is used to compare to the emission, to all these, just to understand the climate changes that have happened in the past. You use a baseline.
Mm-hmm.
And James Hansen uses this baseline in his research.
Right.
But then if Gavin Schmidt uses this number from 1880 to 1899.
Right.
And there you get
slightly cooler.
Yeah, slightly, but you like every
yeah.
Right? So if you add this up and then and now he changed it to 1880 to 1999, he changed it to
okay.
50 to 1900 using a baseline from somewhere else, not using the same data set he used himself, but using a different data set to get again about 0.03 degrees less warming.
Let's do a little climate 101 education, and on a topic that I think no one ever talks about for some reason. And that is looking at these graphs, either one, or basically the same graph with a slightly different baseline. You'll notice at the beginning of the Industrial Revolution, when we were ramping up the emissions of greenhouse gases, that the world cooled a little bit. And then it slowly started warming around World War II. It peaked and then it dropped. And then in the 70s, it started going up. And you might say, well, wait a second. Why is that? CO2 is a well-mixed cumulative greenhouse gas. It shouldn't be, you know, the temperature, if it's only CO2, should only be going up, maybe sometimes faster, sometimes slower, based on our emissions. But why, go back to the graph though, I want to just explain this one thing that people might not understand. And it's what we're talking about here today.
Yeah, almost.
And that is that in the beginning, we started putting greenhouse gases out, let's call it CO2, but there wasn't a lot of CO2 extra in the atmosphere. And again, global warming is caused by the cumulative amount, not the yearly amount. So back then, the cumulative amount was very small compared to today. But the amount of smoke that was being generated from all these newfangled steam coal plants was very high. So the cooling effect of the aerosols was stronger than the warming effect of the greenhouse gases. Then after World War II, by the way, during World War II, industry obviously was a world war, and so things shut down. There wasn't as much smoke being generated, and so temperature spiked. But right after World War II, we started industrializing, especially in the United States, building new factories and new coal plants and everything like that. And we generated a lot of aerosols. And again, the CO2 is slowly accumulating, but the aerosols were like, boom. And that caused us on a cooling trend until the 1970s when because pollution was getting to be really bad. So we passed the Clean Air Act and made these industrial plants clean up the smoke particles and put filters on them and scrubbers. And we wanted to stop acid rain. So we put sulfur scrubbers on coal plants. And that became the era where the warming from greenhouse gases dominated the warming trend. And we have a steady, until recently accelerating, increase. But this explains a strange thing that some people ask: why did it get cooler at the beginning of the Industrial Revolution? Anyway, that's Climate 101, and
Yeah,
it's totally related to what we're talking about because it's all about aerosols.
Yeah, and here you can see that this line is increasing, right? It's non-linear. So here's linear, and even with these La Niñas here, you can see that even the temperature is increasing, and this will be about 1.5 or 1.6 degrees Celsius.
What's your feeling what's going to happen on temperature for the next, let's say, 2 to 5 years? You know, with El Nino, I don't know if a big enough La Nina kicked in yet, but what do you think is going to happen in the next few years?
This El Nino will be, it might even not be considered a La Nina in the end if you look at the predictions now.
It's not very cool, yeah.
Yeah, so it's about if you compare the climate, the temperatures to you deduct the warming of the region, and then you look at the surface air temperatures in the tropical Pacific, and if it's below the average for
half a degree or something.
If it's below 0.5 degrees Celsius, now really 0.5, not 0.05. if it's 0.5 degrees, so half a degree below the trend for a while, for I think 3 months, then it's considered a La Nina. And if it's more than
so we don't really have that yet. But if we did have it, my guess, and this is my guess, I'm not an expert on this, is that we would drop to sort of 1.4 degrees maybe if we had a significant La Nina.
That's what we wrote as well.
Right. And if you take 1.4 during La Nina, compare it to 1.6 during an El Nino, right, you end up, we're at 1.5 trend.
Exactly. Yeah, using this baseline. And then you have to consider, okay, there's now a solar maximum. So even if we have a La Nina, there's still a bit more sunlight coming in this 11-year cycle. And then
like 0.1, isn't that like a 0.1 effect?
Yeah, it depends a bit on how strong the solar
0.05 effect.
Yeah, so in the end, it depends on how strong the sun is. So some solar cycles it's stronger than other solar cycles, and if it's If it was last time, so 11 years ago, it was not that strong, so that's considered about 0.1 degrees Celsius, so a tenth of a degree Celsius, more or less. And this might be a bit more because the sun is a bit stronger than it was the 11 years ago.
Mhm.
So you have to take that into account. But I think that will last about 2 more years. So even if we have a La Nina, that also causes the during the La Nina even if you have strong La Nina, so if it's more than half a degree, maybe if it's even 2 degrees Celsius below the average of the trend in the tropical Pacific in this region, it's
Yeah.
not 3, 4. Then even then, that might not cause as much cooling as it would if the sun wasn't as strong as it is now. So you
Right.
have to consider that. And
So
then
but by the time the sun gets to a cooling phase, that's going to be what's 11-year cycle. So 6 years from now,
yeah, so
we're going to have a lot more warming from the greenhouse gases and lower sulfur particles and all that kind of stuff. So we're going to be I think it's safe to say we're at 1.5 now.
I don't think we will get indeed. If in 5-6 years, the Earth, even just looking at greenhouse gases, it will already have warmed again at about a tenth of a degree Celsius. So that would also,
right.
even if you have a strong La Nina, then of course we could have a nuclear war or a super volcano going off, decreasing temperatures. But that's,
or do solar radiation management on purpose.
Yeah, within 5 years.
Well, not 5 years, but maybe starting in 5 years is possible. By the way, the attention to SRM, maybe we helped start it on this channel years ago, but is really growing. I mean, it's gone from a taboo. So I had meetings with private funders of this area just a couple of years ago, and it was a totally quiet, secret thing. It was secret because it had so much negative pushback. And now universities are proudly talking about their SRM research at Cornell, University of Chicago, and they're building up teams. It's becoming, I wouldn't say a well-financed, but a better financed research area. And there is so much controversy. By the way, I should mention that next week, we'll be talking more about solar radiation management with Suchi Talati, and we're going to be talking about, and she runs a group. I can't remember the name of it right now, but it's sort of how to deal with geoengineering. It's people interested in geoengineering and the politics of it, and the social issues and all that kind of stuff. So we're going to be following up on solar radiation management next week here on Climate Chat. So listen in for that.
I wanted to drop in.
Yeah, yes, I also wanted to start opening it up for questions. So go ahead there.
Thanks. Yeah. So I just some comments. I wanted to note that we have now entered the age of Mike Judge. We are living in idiocracy.
Sure.
If you haven't seen the film, you must. It is. I cannot. It's so. And in fact. Maya Rudolph was cast as the female protagonist is like it's how is this happening? And when you were talking about early on and about the plants and how they aren't taking up the CO2, all I could think of is the engineering that's going to happen in agriculture that will be equivalent to Brondo. That this is
we're going to use Diet Coke to
yes.
fertilize the crops.
Brondo.
Go see the movie.
It's what plants need.
It's what plants is. I like it, so let's use it on the plants.
Yes, no. I mean, because
by the way, it is true. If you have not seen the movie Idiocracy,
you must.
And it's an old movie, so you could probably see it for free.
20 years.
Services.
Yeah, I think it's been 20 years now.
You should see it. It's weird that, I mean, if you saw it 20 years ago, you would think, oh, this is very funny. What an alternative universe. This would never happen. And you are currently living in that world right now.
A professional wrestler could never be president of the United States, you know, but the guy who used to host on professional wrestling, he's in there again.
And his professional wrestler friend was speaking for him at the convention and everywhere. So,
and we are burning the sugars in our cars. We're not putting it on the land, but we're burning it in our cars. Even subsidizing it.
Well, and so you were talking about a silver lining, and I do agree that, you know, this is one of the beefs I had with Adam McKay. He was saying that he was basically making both sides sound the same. And I agree, there has not been enough action, but that woman had to thread the needle on so many topics as to not hit a third rail and repel people from voting from her. What has happened, I really do not understand at all. I didn't think about election interference until I saw accounts of how there were people in swing states voting for just Trump and then leaving their Republican senator candidates to hang out to dry at an enormous rate. So the state wins Democratic Senate seats, but has lost the presidency or has won the presidency. Yeah. And it's just that doesn't make sense in this climate. So, and I mean, you know, political climate as opposed to the.
Let me share the thoughts of my son, who's 28 and certainly more in tune with younger folks and things like that than I am, I guess. And I don't disagree with this assessment at all. Is that the Democratic Party forever has been, well, especially now, is sort of Republican light, right? Under Clinton, it was centrist. And then we had an election where Bernie Sanders was running against Hillary Clinton, who's a corporate Democrat. And the party, he was doing well. He could have actually won the nomination, but the party did things to make it so he couldn't get the nomination. And the polls at the time showed that he would beat Donald Trump, even at the time, and more than Hillary, by the way, at the time. So there you had a party under Bernie Sanders, who, by the way, compared to Europe, would be like a middle of the road guy, I guess. But for the United States, is considered like socialist Democrat. Radical. And oh my God, how radical! But standing for something. So Trump stands for racism and misogyny and a lot of things, but he stands for something, and people like that. I mean, I'm not going to try to
biased,
whatever. But people saw him as quite strong and doing something. They saw Bernie that way too. People loved Bernie. Think of you remember the passion there was for Bernie? It was nothing like that for Hillary, by the way, except women. They thought, oh well, great, there's a woman president. But if the Democrats actually, instead of embracing Liz Cheney, as my son would say, embraced Bernie Sanders and those ideas and AOC, and actually stood for something, stood for change, stood for helping people, rather than, obviously, it's obvious that the view of the Democratic Party is not very good right now. I mean, they, didn't look like anything, I mean, in terms of standing for something. So, anyway, I don't disagree with him on that. And I think as part of this rethinking, it's not how can we be more in the middle? It's how can we stand for something? How can we have policies that people would get passionate about? Like now Bernie's kind of old now, but
what do they get passionate about? I'm looking at this from overseas.
The price of eggs. That's what they get passionate about. The price.
Well, no, but even Bernie said we're going to really fight climate change,
get passionate about eating cats and dogs, and some squirrel got killed somewhere. Yeah. And that's what happened. Like the day before, people, and that's what was all over the socials from Elon Musk and from Trump and whatever. Some guy, his social media squirrel got killed by the police, and they blamed it on the Democrats. That's what people put on. The nice, cozy, the cuddly, fluffy animal, doesn't have anything to do with the real people's lives, but that's what people vote on. Right? And you can have all these philosophical.
Totally. By the way, let's also talk a little bit more about politics and climate.
Policies. these kind of things, like
totally irrational. No, I'm going to agree with you. First of all, it's totally irrational. Obviously, people aren't voting for their own interests. The people that are going to be hurt the most are the people who voted for Trump. As they say, that it's not really a Chinese curse, but they call it the Chinese curse. May you get what you wish for. And that's a curse, right? So that's going to be a curse for all of us, unfortunately. But my point is, there were a lot of people on this program talking about it too, that, oh, we understand climate change. We understand the risks. We understand that simply saying we're going to lower emissions isn't good enough. We actually have to get, changes in lifestyle. Kevin Anderson, by the way, is very strong on this. And his new thing is the rich are causing climate change. That's what's caused it. We're all rich, and the ones listening. Okay, I'm not disagreeing, but what we're learning is there's a very big difference between what we must do, and by must, I mean if we don't do it, we will suffer unacceptable consequences. That's what must means, okay? So there's a difference between what we must do and what we will do. We're learning that every day.
So
that we are not going to do what we must do. And by the way, it's been true for 40 years. It's not like all of a sudden we're not doing what we must do. Jim Hansen told us in 1988 what we must do. Okay, give a little time for that to sink in. Okay, a few years. Greenhouse gas emissions have gone up 50, 60% since he warned us that we have to reduce them, right? So it's nothing really new. And I think we have to face it, which is one reason why we spend a lot of time here on Climate Chat talking about what I call Plan B. So Plan A is doing what you must do, and that is reducing our emissions, electrifying everything, switching to clean energy. We have to do. By the way, we're going to do that for economic reasons anyway.
Coming. This is coming, Dan. So the silver lining is going to come. My prediction is within 1 year, the chemotherapy will begin, because
by the way, it takes a lot longer to even get it going.
To get it going?
SRM?
Are you kidding me? Right? We have Elon Musk. There isn't going to be any international discussion. There isn't going to be any consensus. This will be
I've heard you say that.
Unilaterally deployed, and they will figure out how to do it. And Trump
you don't have to deploy it if climate change is not a big problem. Even Elon Musk, by the way, is saying climate change is not a big problem. That's the weird thing. One of the many weird things about him is he used to be a champion for fighting climate change. In the last few years, whatever happened to him, one of the things is he has backed off. He's not saying it's not real. It's like a long-term thing that we're going to work on and solve in the long term. So I think that you're thinking that all of a sudden there will be alarm within the Trump administration to fix climate change.
I think that Sarasota and Asheville, and then the probably 10 more that we'll have next year.
Those already happened. He didn't say it was climate change.
I understand, but they're not going to talk about it.
Election. He was trying to win an election by denying climate change and by
yes,
they kill cuddly animals.
And by the way, so one chance is what you're saying, Stacey. One chance is, and this is what I said at the beginning. Now we have someone who officially denies it. So when you have the impacts, maybe the next time you get real action, because right now we don't have any action, but we say we're doing something. So people think, they don't know what to think, I guess. But the other side of it is these bad things happen left and right. And what happens? Somebody like Trump, because he'll be gone by then, says, only I can fix it. And, and remember, we're going to have more immigrants coming because of climate change. It's going to be really bad. So we can coalesce and solve the problem, or
how are we going to have immigrants coming when he's tossing them out right now?
I'm saying climate change already is happening, by the way. So this is not even a new thing, but will make it much worse. There will be mass migration from places that are unlivable, more so than now. That will help authoritarians blame them for all the problems, even though the real problem is everything else and climate. I'm just saying, while I can be hopeful that our response will be the logical response, where we realize there's a problem, we all pull together to solve it, there is another chance, which in the last election we saw happen, that people go against their own best interest because they're scared or they're not paying attention. The million psychological reasons. and they do the wrong thing. Now, what could happen, and what might be the whiplash back from Trump, is rather than having a centrist Democrat that talks about climate change but doesn't really do anything. And again, I'm going to say this: I was on Biden's climate policy committee before he got elected, and I was working with all these great people. And you might imagine if it was me, and it was, I was saying these things we had to do: put a price on carbon, I mean, these really obvious things. I mean, that anyone who was serious about climate change would agree. That was not what was happening in that particular group. It was incremental, subsidizing all the things they're doing. By the way, it was the IRA. It was subsidized wind, which are all great things. Don't get me wrong; they're fantastic things to do, but it's not really solving the problem, right? You're not really addressing the problem. So I'm just wondering.
Window dressing.
I don't know the answer yet, but I think it might be better to have someone who says they don't believe in climate change.
I think that on both sides,
when you're not doing anything anyway,
it is so
versus having someone who tells you they're doing something when they're not on net. Now, Trump might do more bad things. I'm not saying he won't do more bad things.
I think that both candidates were guilty of not addressing it, or on the case of the right,
neither said anything.
Right. So
maybe Trump talked about it more and denying it than Harris talked about doing something about it.
That no one wants to face the American people and have the fireside chat and the adult discussion about what needs to happen. My hope was, when Kamala got elected, that she would do that on all of the outstanding issues. She would do it on climate. She would do it on the Middle East. She would have the conversations that needed to be have the stances that are right in this world, correct to have. If you are moral and care for fellow humans, there is a very clear way to go on both issues. But that is not going to get you elected. If you talk about it, it is too divisive. So she had to thread the needle on so many things to try and get elected. She did not get elected. And now we have the person over at the other end of the spectrum who will deny it or whatever. But we also know I still think there is a slim chance. I mean, Elon Musk is so far off the deep end. I can't say for sure, but the only way, I may have said it here before. I know I've said it to lots of people. The people on the left were the only people buying electric vehicles. By him migrating to the right, he made electric vehicles palatable to people who would never, ever have considered them before. And meanwhile, he knows he can't lose us. Just like Kamala Harris saying she has a gun at home, we're all just like, la, 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 la. I mean, none of us want to have a gun at home. And we don't really want her to have a gun at home or have moderate stances on these things. But she couldn't lose us. There's nothing she could say to lose people on the left, because she was the only moral choice in this election contest. So I'm hoping that some of the things that he has said and shifted and done, Elon Musk, who I'm talking to get himself in with that side of the ticket, that he would it will lean more authoritarian, and there won't be discussion whether it is within the nation or internationally. Things will just kind of get done, and that's the way it will be. And I think that, and if it's in the case of SRM, we have the most military spending on Earth. 1/3 of all dollars spent on militaries are spent by the United States. 45% of the top 20 GDP nations, that's us. That's basically, take out China, we're more than the rest of them. Like, no one can stand up to us. We are the bullies. We're the ones who are causing it. And if that's our way of fixing it, if Musk is shifting for strategic purposes, which maybe, I don't know, that I think SRM would just sort of happen, and then we get hooked on that.
Let me talk. You've mentioned a lot of things. Yeah. Harris, I wasn't saying. I mean, I did say she didn't talk about the climate change during the campaign, but I'm not talking about that. I'm talking about in office, which she is now still, Biden, and I'm assuming Harris in her own way, would talk about climate change a lot and do things like the IRA, but also do things like the Willow Project. In other words, increasing, the United States has increased fossil fuel production like more than any time, under Obama too. So that was my point. My point is talking about climate, but not phasing out fossil fuels doesn't count as real action. Okay, that's number one. Talk about EVs. I should say I bought a new EV yesterday, and I had a Tesla for 12 years. Great car. I had one of the first 500 made, and I bought a Kia EV6. I didn't buy.
What? Wow. Okay.
Because I just couldn't. And by the way, I will tell everybody, the Tesla's a better car. EV6 is a good car. Tesla is just the engineering that goes behind it. It's just well thought out, and it's a little haphazard.
It's built from the ground up. I despise everything he has been doing, but I still, if I had to have a car, which I hope I never have to in my life again, that's what that's what I would want.
Also, I needed to change 12 years in a Tesla, which was a fantastic car. I'm not going to put them down. And even on the price was about the same, actually. But anyway, so I'm just saying that SRM, we're not doing it soon, because if you listen to Climate Chat, you would understand the benefits, how easy it is, whatever, the risks versus the risks of not doing, you would understand that. Very few people understand that. Even the government is not listening to Climate Chat, they're listening to David Keith. We had David Keith on. He's the #1 SRM guy, right?
Yeah.
He doesn't propose doing it. I had a big conversation after our discussion with him, and I was a little surprised. Wait, you're not pushing SRM? He goes, no, we should research SRM, but we shouldn't implement SRM.
Everyone has when they learn about aerosol cooling is, oh, so we should do it on purpose. Right, and then you can have all these experts saying, "Well, it's not that simple, and maybe we should first look at all the regional effects and about the temperature gradient changes and about all these." But the first response which people have, like who don't know anything about it, right? Say, "Oh, cooling. We can have cooling. Well, it's warming, so let's have more cooling." And I think I see more and more people who don't know what they're doing, right? Whether it's two guys playing with balloons, or whether it's politicians, or whether it may be a billionaire in the future who don't have a clue what they're doing, who will just try it. Whether they can do it or not, right? That doesn't. But it is possible already. You can say we need to do it.
No, we had Make Sunsets on. They're doing it now. On the tiny scale.
You have to.
Nobody's doing it intentionally at any reason.
No scale, not at scale.
But we are doing it unintentionally at a scale which is multiple watts per square meter, and at certain regions, multiple degrees of cooling. Right? If you look at India, they are already cooling India by multiple degrees, by emitting millions of tons of sulfur every year over the surface, cooling the surface of India. And then if they are stopping, maybe they're already reconsidering whether they should install these desulfurization systems because they realize the climate effects, right? Because they have the research is already there. Ramanathan et al. Already published a paper showing that during the COVID lockdown, India saw extreme warming at the surface. This 16 watts per square meter I told you about. That's the warming that they experienced because they stopped. They had these lockdowns. So I wouldn't be surprised if some people in India are already having these conversations right now, whether they should start desulfurizing their coal plants. They're already stopping they keep postponing these.
It kills a lot of people, by the way. I mean, that sulfur kills a lot of people. It's estimated fossil fuel burning, which includes coal. I mean, sulfur is about 8 million people a year. 1 out of 5 deaths in the world.
3 or 4 degrees Celsius of warming over India will kill a lot of people.
Kill a lot of people.
That's
By the way,
Yeah,
before we go
so-
further, let me just say to everyone, if you're in the Zoom room and you have a question, raise your hand. If you're in the YouTube chat and you have a question that you want to ask, type QQ : and then your question in the chat so we can identify questions from just everyone talking. And if you're in Clubhouse, I haven't checked Clubhouse, you can let's see.
And I do
see
have
maybe some
two-
questions in Clubhouse I didn't
Well,
read yet.
I have 2 questions in YouTube already.
Okay, so go ahead.
One is from Nadia. Will the right turn usher in a radical intensification of climate catastrophe? If so, by how much? 6 degrees by 2100? 10 degrees? More?
Well, I think it goes either way. As I said, there's the law of unintended consequences. Yes, we now have someone who denies climate change, can be terrible, but he might end up being terrible for the global economy too. And if he is, that will decrease emissions. And at the same time, as I said before, like climate catastrophe is going to continue, by the way, regardless of what he does in the short run. And that now is going to be blamed on inaction, hopefully, to engender more action. You know, because again, I'm going to say it one more time. We weren't doing anything to stop climate change on net. I mean, yeah, it could have been far worse if we hadn't done what we did, but fossil fuel emissions are at a record high. And that's really the only thing that counts, except for aerosols and some land use, deforestation stuff as well. So we weren't addressing it. It's not like we were, and now Trump comes along and he's not. He's going to officially say we're not. And that, I don't know. I gave both sides of the answer there, right? It could end up being good if we recognize this inaction is terrible and these things are all blamed on Trump's inaction. Great. Next person can take real action when they come in. Or that some other authoritarian comes in and says, this is a terrible world. Only I can fix it. And then they believe it, and Fox News goes with it.
What happened last time Trump got elected was that the states doubled down their
Exactly.
climate policy, right?
I think companies are going to do more climate action now that Trump is there. They're going to do it on their own. Renewables are getting cheaper. They're far cheaper than they were 4 years ago. They're going to get even cheaper. We're going to see regular climate action, but the key is to actually phase out fossil fuels. That's certainly not going to happen under Trump. But again, it didn't happen under Biden or Obama either, you know. So we just have to face the fact that, as Kevin Anderson says, we're choosing to fail, and we have to stop choosing to fail. Maybe this will be a wake-up call of somehow to change that up.
So
Leon.
The only person I've seen the politician I've seen talk about the warming effect from reducing air pollution was George Bush, and his father was the one who signed this the amendment to increase the Clean Air Act regulations, and so George Bush Sr. caused much of the desulfurization and other air pollution reductions, and George Bush Jr. was the only one who honestly said, spoke publicly about the warming effect of the desulfurization. And that's, I think that's really mind-blowing, that because I'm not a fan of any of the policies George Bush created, as far as I know. So that, I think that's really crazy. And that was just, I think, 1 or 2 weeks before 9/11 happened. And after that, of course, there was no climate policy whatsoever. I remember Obama said they called the United States the Saudi Arabia of natural gas, and that's of course a factual description of what happened. That the enormous increase in fracking and both oil and gas drilling has now brought the United States to be the top oil producer in the world.
And LNG is even worse than regular natural gas because of the energy that goes into cooling it and compressing it and transporting it and everything. So it's worse than coal. There was a recent paper by Bob Howarth, who one of our first climate chat video interviews ever was Bob Howarth on the Clubhouse days. And,
Well, they are
and
just
that
the
just
same.
came out, and he's right, by the way. It is worse than coal.
Yeah.
And yet we view it, and when we do it, we count it as half the CO2. So we take out our accounting books and say, oh, we lowered emissions by doing this, when we're actually increasing global temperatures. So, we're
And
doing
I
things like
understand.
that.
I understand Stacey calling Trump the devil and everything, but I think if you just look at the numbers, they're just the same. They're
Well,
just the same, right? And yeah, it's really mind blowing that
if
George.
we're looking at just climate, I understand why you would say that, and I don't
I mean, that's what we're
disagree.
discussing here. You can bring up all these other discussions, and I think that's interesting. But this is climate chat. So if we want to have a policy, the women's right chat, we can have a very different discussion. But if
Well,
we're having a climate chat, you just keep talking about the devil and about how horrible Trump is, you can. It doesn't matter, right?
I understand what you're saying. Everyone thinks that their issue is the most important issue. And when
No,
I'm
it's
hearing
climate
climate
chat.
chat,
No,
I
you're not saying
understand.
that at all.
No, but I mean, it is the
If
way
you
it
want to
rolls
have
over. Earlier, Dan, you were saying about Hillary and that women voted for her because she was a woman. And I
And
am
people voted
telling you,
against her
there
because she
has
was a woman, too.
not been a better resume to show up to run for the office of president. If she was in George Clooney's body, she would have been made king. We would have never gotten rid of her. We've never had a more qualified individual run for president. And that
But
she
no,
wasn't
okay,
elected is a
fine.
tragedy.
My
So
point
that
is, if she won, and I think this is Leon's point too, if she won, okay, she probably would have had similar policies as Clinton and Obama on climate change.
And Trump.
Keep in mind, Clinton had Al Gore as his vice president. Al Gore knew all about climate change then. He'd studied it long before. It wasn't like after the election that he learned about it. He knew all those things, and they did nothing on climate change. And they did all these other things, by the way. They got a lot done. They got a lot done, right?
Things would have been different for Hillary. I can't. But for Kamala, I want to believe they could have, because
no, but she was vice president.
The population was not aware. Al Gore was aware.
They were when Biden was president.
Biden was aware. They were all aware of what has been going on, but the American people have not been in a place to receive this information.
Correct.
And and that you are basically saying you will be a one-term president.
Because
you will not get reelected.
You're just denying them information. Except
no, I think Bernie would have done it. Bernie would. He took climate change seriously, and he would have done
denying people information for forever, right? If you don't tell them air pollution is hiding the warming, except for Bush does it, right? You can call them an angel, you can call them whatever. I understand that you're emotionally involved there, but they're just denying people crucial information which they need to be able to take informed decisions on risks. If you have multiple degrees Celsius warming of the northern hemisphere, which people are not informed about because they are denied information, it's gross negligence, right? And they can have nice a way of speaking, and they can make you feel nice inside, but they are just lying to you. They're just denying information from the public, which will get a lot of people killed, which will make my country uninhabitable because of rising sea levels, because of those fucking frauds, right? They are just they want votes. I want votes, so I won't talk about the real cause of climate change. And the other guy,
listen,
they are killing those pets. Right? It's just completely ridiculous, and you can say, okay, they don't want guns or whatever. This is climate chat. We're talking about climate change. We're talking about rapidly accelerating climate change, especially over the northern hemisphere, and we have to live with the consequences. And the whole most climate scientists won't even mention it because they're afraid of losing their funding or whatever. I don't know, or that we might talk about intentionally cooling, whatever. Like, and let alone the politicians. Can you imagine that we have to go to George W. Bush to have any politician talk about this publicly? It's crazy, right? And then, yeah, so
no, wait a minute. When you say about George W. Bush talking about this publicly, you're saying that he talked about it more or did more than other elected presidents.
He's the only one who honestly talked about the cooling effect of aerosols and the warming effect of desulfurization.
In one speech.
In a speech ever.
Okay, but
I give this, maybe Brian knows someone who has talked about it also as well, but I don't.
So Brian, welcome. Are you joining the conversation? What's your thoughts?
Yeah, I'm going to say that Leon is right. Emissions reduction only is a suicide pact for our civilization. And we have to recognize the three legs of the climate triad involving emissions reduction, removing 2.4 teratons of carbon dioxide from the atmosphere, as Eli has mentioned previously, and finally climate repair, using aerosols and other approaches to really reflect enough sunlight and to get us back to reasonable temperatures as we're getting our carbon budget back into balance. Absolutely essential. And it's true, the previous administrations, Republican and Democrat, have failed to distinguish themselves from a burn baby burn civilization. So our challenge and our opportunity is to wake up in the next 4 years, because to quote my good friend, Sir David King, our actions in the next 4 years will determine the fate of civilization for the next 1,000 years.
Agreed.
So
again, one more time, speaking of one of the legs of the triad, solar geoengineering, next week's guest is Suchi Talati, and she is the founder and executive director of the Alliance for Just Deliberation on Solar Geoengineering. So it's sort of a group that's trying to bring all the parties together and sort of figure out what should be done and how it should be done. And we had a guest earlier talking about governance, specifically sort of focused on Europe. This is different. This is not just governance. This is sort of the whole thing, which I think is going to be, they're going to be looking at it differently after the election too. So that'll be interesting to see what's going on there. So that's next week on Climate Chat.
I did want to make a few points. So going back to Stacy's comment about SRM potentially happening quickly, there is one potential scenario, and that is that we do get more, perhaps the same or an increase of the kinds of climate catastrophes we had in the last couple of years, and pressure actually mounts. And remember, early on in the 2024 campaign cycle, Trump, asked the fossil fuel industry for $1 billion to support his campaign. The easy out for them, especially, is SRM, because that takes the pressure in an immediate sense, not in a real sense, but in an immediate sense, off of eliminating fossil fuels. So you could see a sudden shift towards SRM policies and action that drives SRM that blindsides everybody, because the fossil fuel industry would get right behind it in that scenario.
Yeah, because it costs almost. By the way, I should say that so as you know, people know, I invested in carbon capture more than a decade ago, because just realizing it's one of the legs of the triad, we're going to need it. There was no business model for it back then, no way to make money on it, but I said, well, it's technology we're going to need. So one of the ways you should fund it is through government subsidies, because it's waste disposal. It's for getting rid of the old emissions, and there aren't people around to pay for that, so the government has to do it. So guess who signed the first bill to subsidize carbon capture? It was Trump. The 45Q tax credit, which was smaller then, it was increased under Biden, by the way. On the IRA, increased the subsidy, but the original subsidy, which was significant, was signed under Trump. And the reason that happened is because everyone was for it. Trump and the Republicans were for it because the
was
fossil
helping
fuel
the oil
industry sees it
industry.
as a business opportunity for them.
Yeah.
And the climate people wanted it because they realized we don't survive without it, you know, and so everyone was behind this. So it is possible. I do think it is possible, certainly to increase SRM funding, by the way, which is still tiny because we do have so much to learn. I can certainly see that happening under Trump. There won't be a lot of resistance to it, whereas obviously anything that hurts fossil fuels like EVs or solar, you'll see them putting up roadblocks to that. But remember, solar is really cheap. 90% of all the new electricity supply comes from wind and solar, not because of climate. Well, maybe a little bit because of climate, but mostly because it's the cheapest form of new energy. Batteries have dropped 90% in the last decade or so, and they're going to continue to drop. California gets 100% of its energy from non-carbon sources during the daytime when the sun is shining. And then as the sun goes down, you see this sort of this black area of battery power. And it's not a huge amount yet, but it's only been in place for a few years. They built all those batteries just in the last few years.
And a red state, North Dakota, got over 100% of its energy from renewables recently. That's wind. So they're
and Texas too is a huge on wind. I mean,
yeah, they might not be doing as much to facilitate the growth of renewables, but even if they try to slow it down, it's unstoppable at this point, simply on economics. But it couldn't happen fast enough. But I did want to go back to something that Leon said regarding information. The suppression of information. This is not so much at the level of scientific research and its interface with policy. But Trump recently put out a video on how he wants to crack down on interference with freedom of speech on social media. I put a link to Raven, the science maven, organizing something to combat the tidal wave of disinfo that we can expect on social media. And Leon, I would encourage you to take a look at that, and if it interests you, get in touch with Raven.
Okay,
Pardon?
why don't we finish up with with final thoughts, maybe if possible. Give some positive thoughts if you have any for leaving.
One question from YouTube that Leon, do you or Jim Hansen have any influence in Earth's digital twin being created with NVIDIA's chip?
Not that I know.
Okay.
I can say this, Stacy. All models are wrong. Some models are useful.
You're not the
All
first
models
to say
are
that,
wrong.
but...
Some models are useful.
I'm just quoting someone.
Yeah.
Okay.
So I think we should finish up. First of all, I want to thank Leon for, first of all, giving us a great primer on what's going on with the climate right now, giving us a better understanding of the ins and outs of how it works and what some of the changes are. You don't see that kind of primer very often, and focusing on what to me seems to be a really, really obvious thing with the shipping and not getting enough coverage on that. But so thank you for that. I also think we had an interesting discussion. I would say on politics, the political climate side, a couple of things. First, focusing on climate, like we all, I guess everyone watching this, but me for the last 20 years of going around giving talks, telling people how bad it was going to be, and yet seeing nothing happen, and then seeing it actually get that bad, and not as bad as it will be. Sort of gets your mind ready for a world where the world doesn't do the right thing. So the Trump thing is one more example of that. I think if you're in climate, you're a little bit more mentally prepared, although it's going to be bad in many, many social ways, not just climate ways. But I do think there's a possible unintended consequence of having someone who doesn't believe in climate change in the White House while climate catastrophes continue to scale up. There could be a positive impact from that. It could go either way, but I think we have to fight to make it go in the right way. I do think that the next time that climate people get into power, they have to be far more serious, not just talking about it, but far more serious of the kind of action that's needed. And as Brian was saying, there's like 3 parts to it. We have to cut our emissions drastically, which means not focusing on subsidizing renewables, but focus on phasing out fossil fuels. If you phase out fossil fuels, the renewables will fill it in automatically and save money, save trillions of dollars, by the way. And we've had lots of shows on that. We'll do more. The second thing is, it's already 2.4 trillion tons of CO2 that we've emitted. About 1.1 or so is still in the atmosphere. That's a lot. That's too much. Because Leon's telling us what the forcings is a doubling of CO2e, which is way too much, and we haven't seen all the warming from that yet. That will be catastrophic if we allow that to happen. So we have to reduce that. We can. We're not, but we could. So we have to do that. And third, to buy us some time to get the first 2 done. My guess is, whether Trump is there or not, and I don't think as fast as Stacey is saying it, but reasonably fast, we're going to, first of all, increase research on SRM, and we'll probably try it out, maybe within a decade. There's a lot of work to be done, by the way. You need to build new planes. I mean, you can do experiments and everything, no problem. You can do those tomorrow, but to really deploy it at scale, there's some engineering. It's an engineering problem more than a scientific one. But we still don't understand all the ins and outs. What happens to the monsoon in India or the Amazon if we do it? And we need much, much more research. Very little was going on. So we need more serious research to do all the modeling, to understand it better, try some experiments, see if we have the numbers right. We do know, since it happens a few times a century with a large volcano, that it's not that bad. I mean, there are negative side effects, but they're not catastrophic. We do know that continued warming will be catastrophic. And we pass an AMOC tipping point, that's forever. It's called an irreversible tipping point. It's not just an irreversible tipping point. Next 1,000 years, you're stuck without an AMOC, and that won't be pretty. So we got a lot of work. I thought it was a good discussion. Any final thoughts? Leon?
Yeah, I just think what we didn't really talk about is the effect of hiding the real warming. And of course, that's what aerosols have been doing.
Correct.
And while aerosols have been doing that, the politicians, except for one time publicly, as I already mentioned, have kept this information from the public. While this information is crucial, even if you look at the IPCC report, and you can look up the notes of these discussions, and you can see that Saudi Arabia and India withheld, caused the information about sulfur cooling from the summary for policymakers to be removed, to keep the information from the public. Of course, it's in the small print, but nobody reads that. Right, so it's in the 4,000 pages, but the information in the front, and even the scientists that are sharing this information don't do that. They keep the information from the public, especially with regards to risks. Right, of course, if you look at the global energy imbalance and the forcings, it's there, and I already discussed that there are some problems there as well, but if you talk about risk, if you talk about these monsoon changes, you talk about monsoon changes with regards to increasing emissions, but the monsoon can also change from decreasing emissions. The monsoon system shifts. If you decrease emissions, it also shifts. And and people need to know that. People need to be made aware of it, and they are not. And the same could happen with intentional emissions. You say it can take decades, but the simple example I gave you for India, if they just don't install the sulfur scrubbers at the coal plants, right? It's already happening. Maybe, I don't know if it's intentional. I don't know if it's intentional. They've intentionally been delaying the past 10 years the desulfurization of the coal plants, but it is in fact what has happened. They have been
China too, yeah.
China. No, China Sorry?
China's been doing desulfurization big
No, they
time.
have, yeah, no, but I'm saying India postponed their regulations to desulfurize. So in that way, I think unintentionally, but maybe intentionally, so they have reduced. They have been causing sunlight. They have been doing sunlight reflection methods by allowing their coal plants to emit as much sulfur as they can from their coal, which is very high in sulfur fuel content. So they keep emitting these sulfur particles over India and keeping India relatively cool, unintentionally maybe, but the policy is there. So the effect of the policy is keeping India cool. That's and of course in the long term,
Big health effects of that, but keep it cool.
I wonder what the balance is in terms
we
of,
don't know. Right.
Yeah.
Kill
How
a
many
million
do you
people,
lose?
maybe save a million people, but yeah.
But the effect on heating is one thing, but the effect on the monsoon might be even worse. And that's because
from what? From if it's heating or keeping the sulfur or not keeping the sulfur, which would be worse, the monsoons.
Again, as I mentioned before, the research is not there, so it might go both ways. We need to, so there's hundreds of millions of people, close to or even a billion people. I think 1.3 billion people living on this in this monsoon area because it's so. It's warm. There's a lot of precipitation. There's a lot of nutrients in the soil, so it's ideal for growing food and for feeding people, and so you have this enormous population there. And if what makes it possible to live there changes, if the climate changes, if the precipitation bands change, if the precipitation falls somewhere else, or much more or much less, of course you can have hundreds of millions of people becoming having less food to eat, right?
Well, heat too, by the way, just the heat itself is growing rapidly, making it harder. More droughts, incredible heat, by the way, in India is like unlivable.
Temperatures. But that's with this sulfur,
that's with the sulfur.
With these record high emissions over India, which are kept there also because of the mountain ranges, the Himalaya. So it's also kept in this area. So and 16 watts per square meter of sunlight that's reflected from the surface, which doesn't reach the surface. So you need drying of the land, as you already mentioned, and so these are really, I think, if you would see regulations to keep India cool, I don't think you will hear about it, but I think that might be one example of keeping India relatively cool, but just keep emitting these sulfur particles with the coal plant and making the problem worse on the long term. That is the very definition of the Faustian bargain, which James Hansen phrased in 1990. And that's and India is just one example, but it's of course a big one. And then the rest of the much of the northern hemisphere is more and more facing the effect, because I don't think we will reverse or stop the desulfurization of shipping. So over the Mediterranean, the next year will be very very important, and should take very close watch to what happens there.
If we did, by the way, I guess from a philosophical point of view, if we do reverse the regulations on shipping, that would be purposeful SRM, right? It wasn't purposeful before, but we got rid of it. If we put it back for the purpose of keeping the Earth cool, that would be SRM. I mean, it wouldn't be efficient. It would be very inefficient way of doing it. It's a very unhealthful version.
I think regionally it's more efficient.
Say again? Oh, regionally. Well, yeah, you could do cloud brightening though without sulfur. Well, I guess that's a little bit of sulfur. Well, no, you do like sea particles, right?
Indeed, the kind of particle that would be there. So again, it's climate change. So we're gonna. I work on reducing energy, food, wood burning in developing countries, especially Ethiopia. So I know more about the health impacts of aerosol than most people. 4 million women and children die every year from the health effects. So if this was health chat, we would have a very different conversation here. But if you just look at the climate effects of around Europe, right? You don't, and then you wouldn't care about the health impacts. I think it's of course then you would want to maybe rapidly reduce greenhouse gas emissions, especially methane, to reduce the rate of warming and also keep the oceans cool. And I think Brian can talk more about how to do that with less health impacts.
And
I do want to quickly mention that the two very cheapest forms of solar radiation management are marine cloud brightening and space-based solar radiation management.
Brian?
Yeah, Brian, you had...
First of all, we have some firsthand eyewitness remarks on the failure of the monsoon in June and July of 2023. Dr. Sumitra Das, who heads the Healthy Climate Initiative, was on the ground near Calcutta in the Bay of Bengal and personally witnessed what happens when the monsoon clouds fail in the very hot months of June and July. And the temperatures were approaching those described in Chapter 1 of Ministry for the Future. Now, we would propose for India and for the marine regions to not use sulfate, but to use sea spray and benign natural biogenic aerosols available from algae and other sources, and effectively enable a regeneration of the brightness that we had even 20 years ago, as evidenced by the Ceres satellite and the Big Bear Solar Observatory when it comes to planetary brightness. So there's a great opportunity there. And I want to close with a quote from Winston Churchill, which said, and he said, "You can count on the Americans to do the right thing after they've tried everything else."
That's right. Very famous one. And Stacey, any final words? Anything short? I want to close the room up because we've been going for an hour 45 minutes, and
I dream of CalExit. We might do more on climate. We might do more right by people altogether. We might do a lot less damage.
But Putin was pushing that, by the way.
What?
There was Russian funding behind CalExit.
Oh gosh, that's crazy. Because
that helps, right? I mean, anything to disrupt the government. He's getting gold stars in Russia, I think, for very effective use of his resources and disrupting the world. That's what he's trying to do.
We're the fourth largest economy, and we can stand on our own. And
by the way, for Putin as well, although I guess he doesn't really care about it. Maybe he's like Trump, doesn't care about anybody but himself, so he's not going to be around much longer. But the "may you get what you wish for" curse is certainly going to apply to Russia as well as the rest of the world. In other words, as climate impacts accelerate, they're not going to do too well.
Aren't they?
They do a little well in certain things. They can grow more food for a while. What?
The loss of Arctic ice, they get their,
No, there's some peasant. They also have a huge fire. By the way, you think Canada has fire. Russia's getting huge Arctic fires in places that never happened before.
Yeah, certain.
But I don't want to go into that. That's a whole other thing. We could do a show on what's going to happen to Russia. But the world is getting warmer because we have not taken any serious climate action yet. We have not reduced fossil fuel emissions, period. And whether it was a government telling you they're concerned about climate change, and Leon, you kind of blew my mind when you said, yeah, but under Trump, emissions actually dropped. I'm kind of saying that could happen again. If he crashes the economy through rounding up migrants and doing tariffs, emissions will drop, and he will do a good job for the climate. Tons of people will suffer socially and other things, economically.
We'll move towards
but it will actually help the climate. So
no one's processing the meat. No one's in the meat processing plants anymore.
Well, whatever.
Plant-based diets. Yeah,
there we go. But again, and the other good news, I just want to leave a little good news, for people that are totally depressed about what's happening, is that the move that was happening, regardless of the politicians, because again, the politicians weren't doing anything serious, was that renewable energy is getting cheaper. It is growing rapidly. It's going to overtake coal. I keep making the point, it doesn't matter what the percent of renewables is. All that matters is the absolute amount of fossil fuels. If we are lucky, and it could be as soon as next year or even this year or next year, we might see for the first time a slight drop in fossil fuels purely from the fact that renewables are overtaking. Now, if that is, and EVs and all that kind of stuff starting to have an effect. If that happens, it's not nearly fast enough, but I'm saying that is something that will probably likely to continue. Companies might take more action on their own. States might take more action on their own while Trump is in office. California is certainly going to probably try to do that. And then the rest of the world might also react to make up the slack from the lack of leadership of the US. It all could be the opposite. It all could slip into right-wing fascism, around the world because of more immigration from climate impacts and things like that. So we all have to work at it to make sure that it goes in the right direction. But from a climate point of view, there are scenarios, I'll call them, where this doesn't lead to catastrophe and it actually leads to more action as an unintended consequence of someone coming in who says they're not going to do anything. But we'll see,
I think
and we'll keep talking about it on Climate Chat. Yeah,
I think that's the wake up call, right? The seemingly action from the Biden administration, people get rocked to sleep thinking that does something, but when you get someone like Trump, people know for sure that they might have to act themselves as well, instead of just waiting for the politicians to do their job.
And again, climate change is based on physics. It doesn't care about our politics at all. So we're going to see what we're going to see.
Yeah.
And maybe I'll end with one of my favorite climate quotes from Tom Friedman. And that is, you may not be interested in climate change, but climate change is interested in you. So with that, I will say thank you, Leon, and thanks to Brian, Stacy, Eli, and everyone online who's been giving us feedback. Next week, as I said, we'll talk more about solar geoengineering. And thanks for joining. And please follow, please like. That does help. It helps spread it to other people when you like the program. It'll pop up in more feeds. If you subscribe, that will also help us a lot. We're not doing this to make money or anything. We're just doing it to spread the word. So help us do that. And thanks, everyone. And we will see you next time. Take care and bye-bye.
Thank you, Dan.